Softly now, let your eyes close and let the warm hush of the desert night carry you away. Imagine drifting above the endless sands of Mauritania, where beneath the starlit sky lies a hidden world of concentric rings, whispering tales older than time itself. Here, in the heart of the Sahara, the eye emerges a silent canvas, where wind and water have painted across eons, carving a bull's-eye of stone that beckons the curious and the dreamers alike. In the moments ahead, we will journey through the layers of this geologic wonder, following the echoes of ancient seas, the footprints of nomadic tribes, and the pulse of life determined to flourish in extremes. No grand city of lost marble awaits usually the deeper marvel of Earth's own choreography, where each ridge and ravine is a stanza in a poem of creation. So let your breath slow and your thoughts drift as we explore the rings of the Sahara's great eye, where myth and reality entwine beneath a canopy of millions of stars. The great desert stretches endlessly under a silent sky of copper and gold. Soft sands ripple like waves frozen in time, and above them, the eye of the Sahara's vast geologic bullseye lies, hidden until the sun climbs high enough to etch its concentric rings onto the horizon. Tonight, we close our eyes and drift across this expanse of arid beauty, where time flows at its own pace and the wind carries whispered stories from the dawn of the world. Our journey begins at the very heart of that eye. Barren plateaus give way to sweeping ridges, and ancient ridges to valleys carved by water that existed long before memory. Imagine standing on a windswept precipice at twilight. The last rays of a dying sun stretch across layered rock, each striation a chapter in eons of Earth's history. In these fossilized layers, scientists have read echoes of oceans that vanished and mountains that rose only to crumble again. Beneath our feet, the iron-rich sediment of one epoch rests against quartz-laden strata of another, a silent testament to the planet's ceaseless transformations. As night deepens, constellations awaken above us. The Milky Way spills across a sky free from city lights, a river of stars guiding caravans across shifting dunes for centuries. Every culture that has passed by Tuareg nomads, French explorers, pilgrims felt the desert's hush, where each footstep is a solitary drumbeat against an ancient living canvas. They brought tales of a sacred eye, a wellspring of power and mystery. Some claimed that deep beneath those rings lay hidden chambers, repositories of knowledge so profound that to gaze upon them was to glimpse the mind of creation itself. Legends spoke of a city lost to water-great white walls, shimmering under a torrential storm, its towers submerged by a single cataclysmic hour, leaving only myth in its wake. In the dreams of distant philosophers, this place was Atlantis. When explorers first peered at the eye from space, mapping satellites rendered its perfect symmetry a phenomenon so striking that minds immediately raced toward Plato's description of a sunken kingdom. Could these rings be the remnants of an engineered metropolis, one that rose and fell in tune with the tides of history? But science demands evidence, and so geologists set camp along the outermost ridge. They drilled boreholes, measured seismic waves, analyzed mineral samples. Season after season, they unraveled layer upon layer, finding not carved stones or building foundations, but folded rock, uplifted by gradual doming, and then sculpted by wind and intermittent water flow. The eye, it seemed, was born not of human hand, but of terrestrial forcison eroded anticline, its rings shaped by differential erosion over millions of years. Even so, the sheer precision of its circlesome 100 miles across holds an almost uncanny allure, as if nature itself believed in symmetry and pattern. Night's chill wraps around us, and the desert floor emits a subtle warmth where the sun's heat had sunk deep into sediment. We imagine those ancient rains, gentle at first, then torrential, pouring through ravines and gullies, carving channels that would dry to cracked ribbons, only to be reforged by the next season's deluge. Streams once wound through what is now lifeless plain, leaving behind deposits of clay and silt that shimmer beneath moonlight, a ghostly mirror to oceans long gone. In that silent tableau, one can feel the hush of a story that unfolds in geological time, where human history is but a heartbeat. And though there is no stone city buried in those concentric rings, something more profound emerges: the realization that the land itself carries narratives deeper than any myth. The narrative of the Eye of the Sahara begins here not with Atlantis, but with the Earth's slow, patient artistry, chiseling out a monument that humbles all who stand before it. A hush falls over the desert as a pale dawn light seeps across the horizon, casting long, cool shadows through the yawning gullies etched into the outer rim of the eye. Here, in the earliest hours before the wind can gather strength, every flake of sediment appears suspended in a silent ballet. We move quietly among the broken shards of sandstone, their surfaces etched by millennia of gusts, each groove a subtle index of time's passage. In the pre-dawn chill, the earth itself seems to breathe, exhaling a story that predates the rise of humankind. For centuries, Bedouin tribes have wandered these expanses, guided by a wisdom passed down through countless camel caravans. They speak of a time when the Sahara was not a desert, but a fertile plain, dotted with lakes and cradled by verdant woodlands. In the oral histories recited around smoky campfires, elders recount tales of a great kingdom, its palaces adorned with coral, and its streets paved with polished alabaster thriving at the eye's center. One storyteller, Abd al-Rahim, once described how ancestors would canoe across crystal waters, where now only powdery earth drifts beneath bare feet. These recollections, carried on the desert wind, are as tangible to those who hear them as the rock formations beneath their sandals. We pause at a shallow depression between two concentric ridges, where wind and rare rains have pooled to form a miniature oasis. Green reeds and thorny acacias cling to cracks in the clay, and tiny frogs croak in chorus when water lingers long enough. Here, the land offers a fleeting respite, a memory of moisture in a landscape defined by scarcity. From this vantage, the ridges seem to rise like tiers of a grand amphitheater, their profile suggesting an auditorium carved by nature herself. It is not hard to imagine an audience hearing ancient people assembled to witness ceremonies under a vaulted sky, their voices rising in supplication to gods now lost to legend. Yet, as scientific teams have discovered, the so-called oasis is no relic of Atlantis, but a happenstance of geology and climate. Hydrogeologists tracing the subterranean currents found that seasonal aquifers swell imperceptibly underground, feeding these temporary marshes before retreating beneath the porous stone. Radiocarbon dating of pollen and charcoal fragments embedded in the silt confirmed that wet periods occurred in pulses over thousands of years, each pulse separated by centuries of bone-dry heat. Even the most intense floods, while transformative for the local ecosystem, lacked the volume to carve vast basins or flood ancient walls. Instead, they fertilized sparse shrublands and encouraged ephemeral blooms of desert wildflowers, hues of violet and gold that carpeted the basin before withering under the ruthless sun. Still, the image of a sunken citadel persists in the human imagination. Renaissance mapmakers, poring over Arabic manuscripts, embellished their charts with sketches of a ringed volcano housing a drowned kingdom. Speculative scholars penned essays purporting to decode Plato's account through a frame of Saharan topography, asserting that the concentric rings matched the layout of the lost isle described in Timaeus and Critias. Artisans crafted engravings of trident-wielding gods, overseeing amphitheaters of columns submerged under rippling aquamarine waters. These romanticized visions spread through Europe, igniting fervor among antiquarians who salivated over the prospect of unearthing Atlantean treasure-subsidian scepters, orichalcum ingots, pearl-encrusted armor relics of a civilization that might unlock the secrets of human origins. In the spring of 1972, however, a field expedition, led by Dr. Monique Laurent, a geochemist from the Sorbonne, challenged these dreams with hard data. Laurent's team employed isotopic analysis on mineral deposits, lining shallow fissures, revealing that the chemical signatures matched evaporites left by transient saline lakes, not seawater inundations. Seismic surveys detected no hollow cavities beneath the ridges, only solid rock strata folded into concentric anticlines. Satellite imagery from missions like Landsat further mapped the eye's symmetry, confirming that the feature extended deep into the crust. Its architecture, sculpted by tectonic uplift and successive erosion rather than architectonic design. But science need not extinguish wonder. Walking the rim at dusk, we see the eye transform under a shifting palette of rose and ochre, as if nature herself concedes to artistry when the hour is right. It is here, in this interplay of hard fact and boundless imagination, that the true story of the Eye of the Sahara reveals itself, a narrative of elemental forces so vast that they eclipse any single myth. In the embrace of those ridges, we sense both the grandeur of Earth's creation and the persistent ache in human hearts to believe in lost realms. Night returns, and with it the stars, as if the sky, too, were paying homage to the rings below. We lie on warm stone, lulled by the whisper of wind across sand, and feel the pulse of a story that defies easy categorization. No sunken palace awaits discovery here, yet the Eye of the Sahara remains a monument to the dialogue between myth and realitia, testament that in seeking Atlantis, we uncover something perhaps more profound. The unending rhythm of planet and people, etched in stone and sand, echoing through eons, and inviting each of us to dream. Under the leaden afternoon sky, the eye's concentric ridges radiate heat, transforming the basin into an oven where every breath feels scorched. Yet in the depths of that furnace, subtle life endures. Lizards dart among fissures, their spiny hides shifting in pattern with the surrounding sandstone hues, and hardy shrubs with knobbly, deep roots cling to the scantiest moisture. Along the dry washes, Narrow bands of green mark the courses of rain-swollen torrents that lash the desert only during brief thunderstorms. Here, one can trace slender channels carved by ancient waters, now parched to cracked clay. Their sinuous lines a reminder that what is lifeless today once teemed with currents of possibility. The story of the eye cannot be told without acknowledging the great lakes that once dwelled here. During the African humid period spanning roughly from 14,800 to 500 years ago, the Sahara bloomed, watered by monsoons reaching far beyond their modern range. Paleolacustrine deposits uncovered by drilling show thick layers of calcareous mud and freshwater mollusk shells, evidence of lakes, thousands of square kilometers in size, fed by rivers draining the highlands to the south. Archaeologists have discovered stone tools, pottery fragments, and even the faint traces of hearths on terraces above the current basin floor, indicating that humans once gathered here to fish, hunt, and raise children beneath canopies of papyrus and acacia. In these sheltered gullies, one could have glimpsed the glitter of fish scales flashing beneath placid water, or heard the croak of frogs after a sudden storm. As the monsoon retreated, the lakes dwindled, leaving behind saline flats and wind-scoured arenas. Yet for a time, climate change orchestrated a delicate ballet. Grasslands encircled shimmering pools, and herds of grazing antelopes, buffalo, even early cattle migrated through corridors, now cloaked in sand. Cave paintings on outcrops surrounding the eye portray these scenes with spirited lines. Hunters with spears poised beside grazing beasts. Circles of dancers celebrating a successful kill, and slender boats gliding across waters that spread wider than the eye could see. Those paintings, dating from 8,000 to 5,000 years ago, are a vivid testament to a world transformed by nature's rhythms, where human ingenuity adapted to shifting fortunes of abundance and drought. Yet, amid this flourishing, the land's fragility became apparent. When the monsoon belt collapsed due to gradual changes in Earth's orbit and feedbacks between vegetation and atmospheric circulation, the lifeblood of the region vanished. The Great Lakes evaporated, and the plains hardened into dust. Humanity retreated, leaving behind only the silent artistry of rock art and scattered stone tools. In that departure lies a cautionary tale. Even a flourishing paradise can wither when the forces that nurture it shift their course. It was not until space-borne eyes surveyed the Earth that the world rediscovered the eye of the Sahara. In 1965, the ESA-7 satellite captured the feature in stark relief, its image transmitted across continents and igniting debate. Geomorphologists marveled at its precision. Geologists theorized intracontinental upwarping. Armchair antiquarians whispered of Atlantis reborn. Overhead, the eye appeared as a target painted upon the Dunasan invitation to unlock secrets buried beneath. In the years that followed, aerial surveys and ground-penetrating radar probed beneath the dunes, revealing stratified sediments but no trace of human masonry. Instead, they encountered the larger truth of a shifting crust, where tectonic stresses created a dome that eroded into rings, a phenomenon known as an eroded uplift. Even so, the myth endured, fueled by the human propensity to find purpose amid randomness. Tour operators began offering desert safaris, promising to lead travelers to the real lost city of Atlantis, where they could stand at the brink of discovery and feel the electric buzz of potential revelation. Guests rode four-wheelers across scoured plateaus, stopping at viewpoints where guides unfurled embellished maps of a sunken kingdom. Some nights, under canvas, storytellers spun yarns of Atlantean heirs, wandering the dunes in search of their ancestors' bloodline. These tales married the stark reality of geology with the timeless hunger for meaning, forging a hybrid narrative that thrives to this day. By the mid-1990s, digital elevation models and high-resolution satellite imagery had revolutionized our understanding of large-scale geologic features. Scientists employed radar altimetry and multispectral analysis to map mineral distributions across the eye's rings. They found clay-rich clasts laid down by seasonal floods, iron oxide staining the outcrops in rust-red hues, and gypsum crystals marking evaporitic episodes. Thermal infrared scans revealed temperature differentials between the ridges and the basin floor, correlating with rock composition and moisture retention. These data underscored the eye's origins as a structural domine uplifted region of the crust rather than a circled city. Nevertheless, the eye's allure endures in popular culture. Documentary filmmakers depict it in sweeping helicopter shots, pairing aerial vistas with dramatic music as narrators intone the possibility of ancient civilizations lost to time. Novelists set epic fantasies within its barren rings, imagining warrior princesses ruling subterranean palaces carved into bedrock. Musicians compose haunting melodies inspired by its silent grandeur. Albums named Whispers of the Sahara and Rings of Stone evoking the eye's mythic resonance. Even stage performances have been staged in replica sand dunes, dancers moving in concentric patterns to evoke the geological heart of Mauritania. To visit the eye under one's own power is to witness its paradox. It is at once an emblem of the planet's grand mechanics and a canvas for the human mind's unbounding creativity. Pilgrims in search of authenticity will trek across sand that shifts beneath each step, guided only by GPS coordinates and star charts. They camp on the basin floor, where silence reigns unbroken, save for the whisper of wind and the occasional call of a desert fox. At dawn, the first light reveals the geometry of the rings, and the traveler feels the simultaneous clarity of scientific insight and the stir of ancient wonder. Strangest of all, the eye continues to evolve. Erosion incrementally widens the troughs between the ridges. Flash floods gouge new gullies. Sandstorms deposit fresh veneers of sediment. The feature is not a static monument, but a living, breathing formation, forever molded by elemental forces. In this, the eye reminds us that even the mightiest myths, Atlantis, the lost kingdom at the desert's heart, are themselves subject to the passage of time, their outlines shifting until only memory holds them in place. As twilight deepens, the desert's temperature plummets, and the eye's rings transform into silhouettes of shadow and steel. Campfires sputter to life in isolated pockets, casting flickering light on the faces of modern-day explorers who huddle around to share stories and stare into the glowing embers. They speak of sightings of unexplained light, strange luminescence pulsing at the basin's center, stories likely born of campfire tales and simple illusions of heat and dust. Still, the lure of the unknown draws them onward, bolstered by the conviction that somewhere within those arcs of stone lies a doorway to something profound. One such seeker was Dr. Rafael Mendez, a marine archaeologist by training who, intrigued by subaqueous ruins, turned his attention to the eye in 2008. Armed with ground-penetrating radar and magnetometers, Mendes's team scanned the basin floor in a grid pattern, hoping to detect anomalies suggestive of man-made structures. What they found were not walls or columns, but subsurface lenses of sand and gravel testaments to ancient stream channels. Mendes published his findings in the Journal of Desert Studies, concluding that the eye is a mirror held up to Earth's slow symphony, not a stage set for human drama. His paper dampened hopes of discovery, but amplified appreciation for the planet's silent craftsmanship. Yet, human creativity does not yield so easily to data. Artists and entrepreneurs have installed small-scale art installations on the ridge sculptures crafted from driftwood, metal, and stone, each piece a fleeting testament to passage of time and transience of place. Photographers, drawn by stark contrasts of light and shadow, have produced evocative portfolios that grace the pages of travel magazines, their captions emphasizing both the geological marvel and the whispered legend of a lost civilization. Web forums buzz with theories. Some posit that hidden beneath the deepest sediment lies an Atlantean library of inscribed tablets, preserved in an airless vault. Others claim that electromagnetic anomalies detected in the ring center are whispers of a forgotten technology. What endures through scientific study and romantic yearning alike is the eye's power to captivate. It stands as a reminder that landscapes are living stories, written in rock and sand, subject to interpretation by every pair of human eyes that behold them. Whether one sees an anticline sculpted by wind and water or the blueprint of a vanished empire, the eye of the Sahara speaks to the primal need for story, even when the story proves to be a testament not to human greatness, but to the grandeur of nature itself. In the hush of nighttime, with stars wheeling overhead, the eye rests in quiet dignity. Here, where myth and science meet, we understand that the search for Atlantis led us not to a sunken palace, but to a deeper revelation, that the Earth's own history unfurls in patterns more exquisite and enduring than any tale we could craft. And in that knowledge, there is something immortal, an echo of wonder that no amount of evidence can wash away. Dawn's first light stretches across the eye as a pale wash of watercolors, softening the stark relief of its rings into gentle contours. With the chill of night receding, the basin exhales a breath of warmth, and trickles of light dance across the sandstone, igniting veins of ochre, burnt sienna, and blush pink. This moment, when earth and sky merge at the horizon's edge, invites reflection on the countless cycles that have shaped this land, seasons of verdure and drought, eras when water carved valleys only to vanish again, leaving only whispers of its once mighty flow. Our passage through geological time carries us to the dawn of deep history, long before any human carved a tool. Here, in the Precambrian, the very bedrock of West Africa formed deep beneath an ancient ocean. Pressures unimaginable drove minerals into crystalline assemblies, forging gneiss and schist stones that would later be thrust upward by tectonic collisions. Imagine the core of the Sahara as a battleground of continents, where plate edges slammed together, folded crust into mountain ranges, and buried organic matter under layers of sediment. Over hundreds of millions of years, heat and pressure cooked those deposits into hydrocarbons, hidden beneath the surface remnants of primordial life locked away like fossils in time's vault. When the collision subsided, the Hercynian orogeny left its mark in ridges and folds that would become the outer rings of the eye. The nascent feature lay buried, obscured by layers of sandstone deposited by ancient rivers. It was only with the breakup of Pangaea that extensional forces reawakened this buried dome. As the Atlantic rift widened, the crust stretched and thinned, and underlying magma rose, pushing up a broad bulge. Erosion then took hold, peeling away the softer sediment and leaving behind the concentric ridges of the ionature's own fingerprint etched on a continental canvas. Millions of years later, in a time far more recent, Homo sapiens ventured across these emergent lands, following migrating herds that grazed on freshwater grasses. Archaeologists have identified microlithic tools near the basin's etched arrowheads, fashioned with expert precision, suggesting that even small game was hunted here. Flint quarries exploited bands of silicious rock. Shards of chipped stone discolor the ground like confetti discarded by ancient artisans. Pottery fragments, charred animal bones, and beads carved from ostrich eggshell hint at gatherings feast shared under star-streaked skies. Stories passed between elders and children that would seed legends of lost realms. As centuries turned to millennia, the Sahara warmed and dried. The lakes that once circled the eye shrank until only marshy relics remained, and then those too evaporated. By 20 BCE, the region had become a mosaic of oasis-isolated pockets of life, hemmed in by sand seas, which travelers followed like stepping stones. Camel caravans, introduced much later, traced these routes, establishing salt and gold trade that linked West Africa to Mediterranean markets. Timbuktu's scholars studied Quranic verses while Berber nomads negotiated caravans' safe passage. All the while, the silent rings of the eye watched from a distance, neither aiding nor hindering, but lending their silent vigil to ceaseless commerce. In the 19th century, European explorers sought empirical data to satisfy both scientific curiosity and colonial ambition. French officers mapped the eye's perimeter, naming ridges after generals, and drawing charts that attempted to reconcile local Tuareg maps with Western surveying techniques. Yet even their compasses and sextants yielded only coordinates, not answers to the eye-filling mystery of what lay beneath. Photographs captured paler-than-sky ridges spooling into the distance, but those images, sent back to Paris, remained curiosity-eye-catching landforms with no practical utility. Only later, when geologists recognized the patterns of anticline and syncline, did the eye find its place among the catalog of Earth structures. Standing on the crest of the middle ridge, we feel the weight of time's accumulation, the pressure of rock, the whisper of centuries, the pulse of planets colliding far below. And here, in this sublime silence, we begin to understand that the eye's power springs not from buried cities or lost civilizations, but from the slow, inexorable choreography of earth, wind, and water. In the embrace of its rings, we glimpse both the fragility of human dreams and the resilience of geological forces that endure long after those dreams fade. Thus, as the sun climbs higher, we carry with us a deeper reverence for a world whose story rewards the patient listener and whose greatest secret, perhaps, is the beauty found in understanding its true nature. A wind-stung silence settles over the eye as midday heat ripples above the stones like a mirage. In this sweltering breath of time, our eyes travel across the basin floor, tracing the subtle undulations where water once pooled and driftwood once lay. Imagine torrents surging down from distant highlands, carving ephemeral channels that vanished with the last thunderclap, each rush of water depositing layers of sand and gravel, only for the desert winds to reclaim them later. Underfoot lie these hidden strata, a manuscript of geologic epochs written in shifting grains, awaiting the patient gaze of those who would read its lines. Here, in the heart of the concentric rings, one can almost sense the lazy swirl of an ancient lake, its placid surface reflecting skies now too vast to mirror. Acoustic studies have shown that the basin floor's porosity reverberates like a bell when struck by sudden impacts, meteorites that pepper the Sahara more densely than any other desert. Tiny craters pockmark the sandy apron, each one a cosmic reminder that the Earth's history is also written by celestial forces. When a bolide fragments in the thin air above, it scatters shards of iron and nickel into the tepid ground, mingling the stories of planets and stars with those of shifting dunes and folded rock. Yet even meteoric fragments cannot squeeze human drama from stone. To find that, we turn to the ephemeral traces of ancient inhabitants. At the fringe of the eye, archaeologists uncovered a cluster of hearth mounds where charcoal-stained stones mark communal fires. Through optically stimulated luminescence dating, these fires were lit around 6,000 years ago, when lush grasslands fed the people who lived here. Flint tools lay in scatter patterns around the mounds, their edges worn smooth by countless strikes, and broken pottery shards, painted with red ochre, depict stylized fish, evidence that these communities lived on the edge of water, collecting its bounty before it vanished. As the basin filled and emptied over centuries, human settlements rose and fell like the tide. Some researchers propose that the shifting shoreline created a cycle of migration, with families moving camp to follow receding waters, then returning when rains return. Oral traditions recorded by Sahara nomads speak of a sea of sand that swallowed villages whole, only to spit them back out when the sky wept again. In these tales, the eye becomes a living being, breathing in drought and exhaling floods, its moods dictating the fortunes of all who dared to dwell at its center. It is a story that entwines human resilience with nature's capriciousness, where survival demanded both intimate knowledge of the land and faith in forces beyond mortal control. Through satellite chronologies and ground surveys, we learn that these pulses of habitation corresponded closely with orbital cycles that govern monsoon intensity. When axial precession nudged the African monsoon northward, the Sahara bloomed and lakes swelled into vast inland seas. When that axis shifted away, deserts returned, and human presence retreated to oases far beyond the eye's concentric ridges. In this rhythmic dance of astronomy and climate, the Sahara emerges not as a static wasteland but as a living, breathing biomites, eye a focal point where the interplay of cosmic mechanics and earthly processes writes its most vivid chapter. Late afternoon shadows stretch long across the eye's inner ring, and the air cools enough to hear the distant flap of a francolin bird's wings. In the hush that follows, one senses the basin's deep time, converging with the present moment, ancient crust pressed into concentric arcs, now hosting a few tenacious shrubs and their silent companions. Here and there, ephemeral waterholes gather beneath overhangs, sustaining small populations of insects and rodents that skitter across the cracked clay before vanishing when the sun regains its dominion. Such fleeting oases offer a reminder that even in the heart of aridity, life persists through cycles of scarcity and renewal. These ecological islands never supported dense populations, but they formed vital links in Saharan corridors of biodiversity. Genetic studies of desert frogs living in these pools reveal lineages that diverged tens of thousands of years ago, suggesting that the eye's microhabitats acted as refugia during arid peaks. When rains returned, these populations spread, carrying traces of their desert ancestry into broader ecosystems. In this way, the geology of the eye influenced the tapestry of life across North Africates, concentric ridges not merely inert stone, but active participants in evolutionary history. Meanwhile, the human lens continued to refocus. In the 2010s, a team of remote sensing specialists used LiDAR-equipped drones to peer beneath sand veneers and map subtle elevation changes across the ridge slopes. Their digital elevation model revealed faint anomalies, linear depressions, and rectangular patterns that some interpreted as the footprints of ancient enclosures. News outlets ran headlines declaring possible Atlantean fortifications discovered, only for geologists to temper excitement with caution. The anomalies aligned with jointing patterns in the bedrock and differential erosion along bedding planes. What looked like walls were, in truth, the Earth's fractures laid bare by millennia of wind and sand. Yet the headlines had their effect. Adventure seekers from Europe and North America arranged private expeditions, eager to stand where drones had spotted secret structures. They arrived in sturdy forks, GPS coordinates in hand, trudged across dunes, and snapped photographs of shadows marking subtle ridges. Some left small cairns of stone. Others buried time capsules filled with letters to future explorers. In doing so, they became participants in the eye's evolving mythos, adding their own layer of human narrative to those ancient concentric rings. Night falls quickly in the desert, and in the glow of headlamps, these modern pilgrims trace the same paths once used by nomads. They peer into deep gullies, sweep metal detectors across the ground, and sift through wind-blown sediment. And though they find no Atlantean gems or orichalcum ingots, many report a profound sense of connection, as if the eye had opened a door not to a sunken city, but to the deep history of Earth itself. In that realization, science and myth converge. The eye does not hide a lost empire, but it does reveal a more wondrous truth: how the interplay of rock, water, life, and human imagination can create a story that endures beyond the boundaries of time. With the desert's nocturnal chill deepening, we turn our gaze upward to the celestial tapestry strewn above the eye. Here, astronomers find an uncommon clarity. The lack of light pollution offers views of the Milky Way so vivid that constellations appear to untangle themselves against the black velvet sky. Bedouin star lore, passed down through generations, assigns each cluster a story Orion as a hunter stalking prey across dunes, the Pleiades as sisters gathering water lilies by phantom lakes. For those who spent nights camped within the eye's rings, the sky was both guide and companion, its stories intertwining with the land below. One evening in 2017, a team of astrophysicists installed an array of small telescopes on the basin floor to monitor variable stars and meteoric activity. Their project, called Desert Skies, aimed to engage local youth in science while capitalizing on the region's pristine viewing conditions. As they calibrated their instruments, nomadic children peered through eyepieces, their faces alight with wonder. To them, this was more than an academic pursuit. It was a reclamation of ancestral knowledge, a bridge between traditional cosmology and modern astronomy. Through their eyes, the eye of the Sahara became not merely a geologic curiosity, but a portal to the cosmos itself. Back on Earth, the telescopes recorded unexpected lunar reflections, earthshine, bright enough to cast faint shadows on the basin floor. Each night, the eye mirrored the rhythms of the moon, its concentric rings bathed in silvery light. Photographers captured these moments in time-lapse sequences, showing shadows sliding across the ridges like spectral serpents. The resulting footage went viral, inspiring a new wave of interest in the eye and renewing conversations about its sublime grandeur. Yet even as social media buzzed with images, scientists reminded viewers that no Atlantean secret lay waiting, only the interplay of light and stone, of sky and desert, yielding endless beauty. In the heart of this spectacle, a broader truth asserts itself. The eye of the Sahara thrums with stories at every scale, from microbial life hiding in moisture pockets to meteor showers blazing across the sky. Each narrative thread weaves into a tapestry that spans eons, connecting Earth's deep past with the hopes of young astronomers and the dreams of adventurers. It is a living monument to the vastness of time and the enduring power of human curiosity, urging us to look both inward at our own origins and outward toward the infinite horizon. As dawn treads the horizon once more, the eye's rings glow with renewed intensity, each ridge outlined against the pallid sky like the silhouette of some ancient amphitheater. The desert's cool breath lingers in the air, carrying the scent of warm sand and the distant whisper of wind through scrubby brush. In this quiet interlude before the world awakens, we pause to consider the eye's legacy. Legacy not of buried cities or sunken palaces, but of a landscape that speaks with eloquence through stone and sand. Scientific surveys continue to refine our understanding. Geochronologists apply cosmogenic nuclide dating to boulder surfaces, calculating erosion rates that suggest the eye's ridges have persisted for upwards of 10 million years. Paleoclimatologists drill cores deep into adjacent dune fields, reading trapped air bubbles that record humidity swings and atmospheric composition over glacial cycles. Even as each dataset dispels fragments of myth, showing us that the eye is an eroded uplift, that its oases are seasonal, and that no Atlantean architecture lies hidden, the feature's enchantment remains undiminished. For beyond the data lies the realm of the soul, where landscape and legend entwine. Poets have composed odes to the eye, extolling its concentric rings as symbols of eternity and cycles of transformation. Painters have captured its essence on canvas, layering pigments to mimic the rich ochres and umbers of the ridges. Musicians have woven its name into sonatas, their notes circling themes as harmonically resonant as the eye's curves. In every medium, the eye of the Sahara transcends scientific classification to become an emblem of human wonder, a reminder that in seeking answers, we uncover questions more profound. And so we depart from this place of stone and story, carrying with us echoes of wind across ridges, glints of starlight on sand, and the pulse of time measured in centuries and millennia. We leave no chiseled walls or sunken palaces behind, only the imprint of our footsteps on shifting dune sand, the unspoken promise that the eye will endure long after our own voices fade. In its rings we find not Atlantis reborn, but something richer, the testament of a living planet and the undying spark of imagination that compels us to explore, to inquire, and to dream. The desert air softens as twilight drapes the eye in violet and indigo hues, the last warmth of day lingering in every grain of sandstone. In that glowing silence, the concentric ridges take on the character of an amphitheater carved by geologic patience, their walls rising like terraced seats awaiting an audience unseen. Here, rather than a city of stone and mortar, we discover an edifice of time itself, a monument hewn not by human ambition, but by the imperceptible, inexorable work of wind, water, and crustal stress. Our mind's eye traces the ridge's arcs as if following an ancient code. In cross-section, each band of rock tells a distinct tale. The outermost ring-pale quartzite, its granular surface hinting at primordial beaches long since vanished. The middle ridge layers of iron-rich sandstone, rusted by oxidizing waters and compacted under thousands of meters of sediment. The inner ring calcareous siltstones bearing fossil fragments of fish and freshwater snails, residues of lakes that once pooled here under humid skies. These strata stand not as chapters in a mythic polity, but as chapters in Earth's biography, each spanning millions of years. As dusk deepens, red foxes emerge from hidden crevices, their bushy tails brushing the sand as they hunt for insects drawn by evaporative moisture. Their paw prints melt into ephemeral tracks, soon erased by the evening breeze, a reminder of life's fleeting spark against the backdrop of geologic eternity. In pockets where subsurface springs bubble to the surfaceary but persistent trees stand in still pools, and dragonflies dart above the mirror of water. Such microhabitats serve as lighthouses of life, sustaining communities of amphibians and crustaceans adapted to abrupt changes in moisture. These tiny ecosystems bear witness to the resilience of living things, thriving in a place defined by extremes. Above, the first stars emerge. The Southern Cross, unseen from these latitudes in our era, once climbed higher in the sky during the African humid period, but Orion and Taurus hold sway now, their stories carried by Tuareg griots as navigational and moral guides. Under this vault, caravans crossed the Sahara, trading salt, gold, and knowledge tales of kingdoms to the west, scrolls of knowledge to the north. These journeys forged connections between cultures, yet the eye itself remained a silent sentinel, more a symbol of continuity than a participant in commerce. Its remote location barred it from major trade arteries, preserving its mystery and leaving it to be rediscovered by modern explorers centuries later. In the 20th century, UNESCO deliberated whether to designate the Eye a World Heritage Site. Conservationists argued that the fragile desert ecosystem and its endemic species merited protection, while geologists emphasized its value as an outdoor laboratory for studying eroded uplifts. The proposal stirred debate among Mauritanian authorities, global scientists, and heritage advocates. Should this place be preserved for its ecological importance, its geological significance, or its mythic resonance in human imagination? Ultimately, a compromise was reached. The Eye would become a protected geological park with regulated access and educational programs, highlighting both the scientific and cultural layers of its story. As night deepens, the desert temperature drops sharply, and the Eye's ridges fade into a tapestry of moonlit silhouettes. We stand at the basin's center, letting the vast quiet settle around us, and realize that the Eye's true power lies not in lost palaces, but in the fusion of timescales human, ecological, and geological woven into one seamless narrative. In that moment, we understand that seeking Atlantis here was never truly about finding a city. It was about recognizing our place within Earth's grand continuum, where the smallest grain of sand and the mightiest tectonic shift both belong to the same unfolding story. Under the first stirrings of dawn, the Eye's concentric rings glow again, each layer diffusing light into soft pastels. At this hour, researchers unfurl canvas tents at the outermost ridge, setting up seismographs to record microtremors crisscrossing the basin floor. These instruments detect the faint hum of the earth, vibrations too subtle to feel but powerful enough to reshape rock over millennia. By analyzing wave speeds and attenuation patterns, geophysicists map subsurface density contrasts, confirming that the ridges are solid cores of denser rock and the basins are infilled with less consolidated sediments. Such precision data dispel any lingering whispers of hollow chambers or sunken vault shear. The Earth's architecture is open and unadorned, revealing the craftsmanship of natural processes in exacting detail. Yet for every dataset that clarifies the Eye's composition, another question arises about its broader environmental context. Paleo-environmental studies draw upon pollen grains preserved in lacustrine clays from adjacent basins, reconstructing a shifting mosaic of habitats. During peak humid phases, papyrus swamps and gallery forests girdled the Eye's inner ring, supporting ungulates whose fossils are now unearthed by desert winds. As monsoons waned, endemic grasses replaced forests, and eventually thorn scrub claimed the terrain. Human inhabitants adapted in lockstep, transitioning from fishing and foraging societies to pastoral nomadism, then to trans-Saharan traders moving camel caravans under star maps. In each cultural inflection, the Eye was a constant, a landscape feature around which communities organized their calendars, belief systems, and survival strategies. Reflecting on this intertwined legacy, anthropologists note that the desire to envision Atlantis here speaks to a universal impulsetto imbue landforms with projected meaning. The concentric rings echo the city within rings motif common in world mythologies, the celestial mandala, the ziggurat's terraces, the fortified acropolis. In these archetypes, circular forms symbolize protection and centrism, the idea that the world's axis mundi anchors reality. When ancient texts described Atlantis as a series of concentric moats and walls, the striking similarity to the Eye ignited imaginations. Yet unlike a constructed mandala, the Eye's rings are not sacred by human decree, but sacred by geological happenstances. Symmetry, a cosmic accident that nonetheless resonates with fundamental patterns of symbolism. To modern pilgrim scientists and romantics alike, the eye offers a meditative refuge. Sound healers host nocturnal ceremonies within the basin, using gongs and drums to evoke primordial rhythms, while yoga practitioners lead sunrise salutations atop the ridges, greeting the solar cycle as a living metaphor for renewal. Photographers time their shoots for the golden hour, when shadows stretch long and contrast is gentle, capturing images that circulate widely on social media. These digital artifacts perpetuate the eye's allure, each new photograph a brushstroke in the living canvas of the Sahara's masterpiece. But beyond Instagram feeds and academic papers, the eye's deepest gift may be the perspective it lends. Standing at its center, one senses the vastness of time, how rivers deposit sediments, mountains rise and fall, forests bloom and perish, human empires flourish and fade. In this synthesis of scales, the quest for Atlantis becomes less about recovering lost glory and more about discovering humility. The knowledge that our own chapter in Earth's story is ephemeral, yet part of an unbroken narrative that stretches into the future. A late afternoon wind stirs dust along the basins, and the eye's rings come alive with shifting patterns of light and shadow. In that kinetic interplay, one discerns a metaphor for the dance between permanence and change. Rock layers that endure for eons contrasted with sand grains that shift with every zephyr. Throughout history, storytellers have seized upon such paradoxes, weaving tales of civilizations rising only to be reclaimed by time, Atlantis being the most perfect exemplar. Yet as we stand amid those concentric ridges, it becomes clear that the Sahara's own epic transcends any single narrative of triumph or tragedy. The most recent chapter unfolded in 2022, when a coalition of Mauritanian universities, partnered with international foundations, launched the Eye Heritage Initiative. Its mission: to document local oral histories, catalog endemic flora and fauna, and develop sustainable ecotourism that benefits nearby communities. Village elders shared stories of ancestors who revered the eye as a sacred placing axis where the sky met the land, while youth volunteers mapped spring-fed water points, ensuring their preservation against overuse. This integrative approach bridged scientific rigor with cultural stewardship, recognizing that the eye's care depends on honoring both its living ecology and its place in human memory. In winter months, when northern winds usher cooler air, biologists conduct nocturnal surveys to study migratory patterns of bats roosting in rock crevices. These mammals play a critical role in pollinating ephemeral desert blooms, and their movements recorded via ultrasonic detectors reveal how the eye's microclimates support biodiversity corridors across the Sahara. Meanwhile, satellite-tagged raptors follow updrafts along the ridge flanks, using thermal currents to soar with minimum exertion. Observations like these reaffirm that the eye is not a static relic, but a dynamic system, where geology underpins life, and life, however, sparse accentuates geology. As day yields once more to dusk, we reflect on how the eye's narrative has shifted from hopeful speculations of Atlantean ruins to an appreciation of geological wonder and ecological nuance. Perhaps no single story can contain the grandeur of this place. Instead, it invites countless perspectives: the geologist's ledger of strata and faults, the archaeologist's catalog of tools and hearths, the poet's homage to concentric beauty, the elders' whisper of ancestral reverence, the scientists' chart of bat echolocation calls. All these threads form a tapestry richer than any myth of lost city stone woven from stone, sand, life, and human imagination. And so, as the stars above the eye emerge again, we allow ourselves to rest in uncertainty in the recognition that some mysteries may never be fully solved, and that this very unknowability is part of the eye's enchantment. It beckons us not to conquer or decode, but to listen to the wind singing across the ridges, to the quiet heartbeat of the earth beneath our feet, and to the echo of our own curiosity resonating through time. In that silence, we discover a truth more profound than any legend, that the eye of the Sahara is not an ending but an invitation to explore, to reflect, and to dream without limits. Morning light spills across the eye's inner basin, and with it comes the soft murmur of human voices carried on the breeze. Researchers have arrived to erect a temporary field camp. Solar panels gleam beside canvas tents, water barrels stand ready to refill from the nearest borehole, and satellite dishes point skyward, linking this remote site to laboratories half a world away. Their mission is twofold. First, to conduct a detailed geomorphological survey of the innermost ring, and second, to record local oral histories from nearby nomadic families whose ancestors once camped among these stones. As geologists mark out quadrants for sediment sampling, anthropologists arrange seating on rugs beneath the acacias, where women and men gather to share memories of flooding rains, migrating herds, and whispered legends of a vanished kingdom. Among them is Fatimata, a griot whose lineage traces back generations of storytellers. She cups a steaming cup of tea and recounts how her great-grandfather, riding a camel caravan in the 1920s, first glimpsed the eye from a distant past. He thought it was an oasis, she says, her eyes alight with the firelight of anecdote. We learned later that it is an oasis of time, not of water. Her words prompt murmurs of agreement. The idea of an oasis of time resonates deeply here, where every ridge embodies epochs of change. An elder named Kader adds that in his youth, the eye was a place of initiation. Young men would spend nights sleeping on the sands, accompanied only by the stars, until dawn's first light revealed the Rijiza symbolic awakening to the world's vastness and the individual's place within it. Meanwhile, the geology team drills shallow cores in a crescent-shaped swath near the center, recovering samples that reveal fine laminations of silt deposited during rare flooding events. Each stratum tells a story. One layer of dark organic mud speaks of a spring that once bubbled beneath the basin floor. Another of pale gypsum crystals marks an era when the lake's salinity reached extremes. When these cores are analyzed back at the university, they will help reconstruct a climate chronology that spans the African humid period to the present hyper-arid state. Already, preliminary readings suggest that the basin experienced at least 3 major wet phases each, lasting several centuries, interspersed with prolonged aridity. These rhythms, recorded in stone, mirror the waxing and waning of human presence documented by the anthropologists' interviews. At midday, a sudden gust whips fine sand across the camp, and all heads tilt skyward to watch a swirling dust devil spiral along the ridge crest. Cameras click, instruments pause. For a moment, we are reminded that the desert is a dynamic system, where even the smallest whirlwind can shift the landscape. When the dust clears, the field teams resume their work, but the incident lingers in everyone's mind. Here, science and spectacle meet. The same geological forces that sculpt the ridges also generate ephemeral art in wind and dust, reminding us that the eye is not merely static rings of rock, but a living tableau ceaselessly animated by elemental energy. As afternoon fades, Fatimata and Kader prepare a communal meal of millet porridge and dried goat meat. Around the crackle of the campfire, they speak of the eye's future, hopes that the protected park designation will foster sustainable tourism, that researchers will continue to honor local knowledge alongside scientific inquiry, and that children born in nearby villages will grow up understanding the eye not as a relic of myth, but as a source of pride and identity. In the hush that follows, broken only by the hiss of embers and the distant cry of a desert fox, we sense the convergence of past and future, of myth and method, of human aspiration and Earth's deep time processes. And as night descends, the concentric rings fade into shadow, leaving behind the promise of stories yet to be unearthed in the interplay of rock, memory, and hope. Under the veil of night, the eye transforms into a natural amphitheater for the stars. Away from any encroaching light pollution, the sky above shimmers with constellations that guided travelers across the Sahara for millennia. This evening, a group of astronomers sets up portable telescopes on the outermost ridge, calibrating mirrors and aligning mounts by referencing Polaris and Betelgeuse. Their goal is to capture long-exposure images of the Milky Way arching directly over the eye's center, a celestial bridge linking Earth's concentric rings to the galactic core. As lenses track meteor showers and track the subtle drift of satellites, camera shutters click in unison, each frame a testament to the synergy between human ingenuity and cosmic spectacle. Meanwhile, back at the basin floor, soundscape artists have erected an array of microphones to record the desert's nocturnal soundtrack, the whisper of wind across rippled sand, the echo of a distant jackal's howl, the eerie hum of insects awakened by the cool night air. These recordings will become part of an immersive exhibit in Nouakchott, where visitors will don headphones and be transported audibly to the heart of the eye. The artists explain that by layering natural sound with recordings of Tuareg oral poetry, they hope to evoke the multi-sensory experience of being here where silence is never empty, but pregnant with history and possibility. At the same time, climate scientists deploy a network of thermal sensors buried a few centimeters below the surface in a radial pattern emanating from the eye's center. Over the next year, these devices will capture temperature fluctuations that reveal how heat is retained differently by the compacted ridges versus the looser basin sediments. Such data are vital for modeling future climate scenarios, especially as global warming intensifies. Early results already show that the inner basin retains heat longer into the night, creating a microclimate that could influence local weather patterns and observation that may help refine regional climate models for the Sahel and Sahara alike. As the first pale light of dawn begins to glow, all three teams converge at the central campfire to share their findings. The astronomers triumphantly display star-field composites. The sound artists play back a montage of nocturnal ambiance. The climate researchers present preliminary thermal graphs. over steaming cups of mint tea. They celebrate the multidisciplinary mosaic of insights that the eye of the Sahara continues to yield. In doing so, they honor a tradition as old as time, seeking to understand our world by weaving together stories from rock, sky, and living memory. And as the sun rises to greet a new day, the concentric rings stand silent witness, patiently awaiting the next chapter in a saga that bridges myth and reality, science and soul. Morning light filters softly through high-altitude cirrus clouds. As we rise at the eye's rim, the air still cool from night's deep chill. With cups of sweet mint tea in hand, we gather to prepare for a day of exploration along the eastern flank, where erosion has carved dramatic gullies that reveal cross-sections of the eye's stratigraphy. Underfoot, the quartz-rich sandstone glitters faintly, each grain a record of an ancient beach, long since submerged by shifting seas and buried beneath layers of sediment. As we descend into a prominent canyon, the walls display a panorama of color-band scream white limestone, tinged with rust-red ironstone, interspersed with streaks of veined quartzite. These layers, tilted by tectonic uplift and bent by crustal forces, are more than static displays. They represent chapters in a saga of supercontinents, assembling and fracturing, of shallow seas advancing and retreating across vast expanses of Proto-Africa. Each step deeper into the gorge brings us face to face with weathered fossil imprints of nautiloids and spiral-shelled ammonites, embedded in slabs of shale that once formed on the floor of a Paleozoic ocean. Paleontologists on our team pause at these finds, delicately brushing away wind-blown sand to reveal the spiral whorls of shells that lived some 400 million years ago. These remnants of marine life underscore the staggering depth of time encapsulated in the eye's geology, where now only arid air stirs once teemed ecosystems of trilobites and early fish, whose mineral-laden remains would eventually metamorphose under pressure into the rock we tread today. Further along, we encounter a narrow side canyon where intermittent springs have fostered a ribbon of greenery. Tamarisk shrubs and desert palms cluster around trickling water, their roots anchored in fissures where moisture lingers. Here, ecologists measure soil salinity and catalog plant species, noting how some but not all survive in brackish conditions. Their findings reveal adaptations honed over millennia, succulent leaves that store precious fluids, deep taproots that tap into underground aquifers, and hairs on stems that trap dew on clear nights. Small lizards and geckos skitter amid the rocks, their mottled skins blending seamlessly with the multicolored strata. In this narrow corridor, the interplay of geology and biology becomes tangible. Rock fractures channel life's essentials, and life, in turn, leaves its mark on the rock root's widening crevices, lichens etching pale patterns on stone. At midday, we emerge onto a ledge overlooking the basin below, and the full breadth of the eye unfurls in concentric arcs that recede into the distance like a vast amphitheater. The sight is humbling, a natural colosseum sculpted over eons, its concentric walls eroded by wind and water into the mesmerizing pattern that so captivated early satellite observers. Here, geographers use drones to capture high-resolution imagery, stitching together orthophotos that will enable tourists to navigate with minimal impact on the delicate terrain. Mapping specialists overlay these images with satellite data to model future erosion scenarios under different climate projections. Already, They predict that flash flood intensity may increase in coming decades, deepening gullies and accelerating the retreat of ridge flanks. In this way, the eye is not merely a static relic, but a dynamic landscape, one that continues to evolve and one that we must steward carefully if its story is to persist for generations to come. As the sun begins its descent, painting the canyon walls in warm hues of amber and rose, we set up a temporary lab to analyze soil samples from various elevations. Chemists test for mineral composition, determining the proportions of quartz, feldspar, and clay minerals, which will help reconstruct the basin's paleoenvironments. By comparing isotopic ratios of oxygen and carbon, they estimate the temperature and salinity of ancient waters that once pooled here. Their preliminary results suggest that the Eye's lakes underwent dramatic fluctuations, alternating between freshwater phases that supported abundant life and hypersaline episodes when evaporation outpaced inflow. Each oscillation left a distinct fingerprint in the sedimentary record, one that speaks not only to past climates, but to the resilience and fragility of ecosystems entwined with these rhythms. Night finds us around the campfire once more, this time recounting the day's discoveries under a dome of stars so brilliant that the Milky Way appears as a luminous river across the sky. We share reflections on how the Eye's grandeur lies as much in its ongoing process as erosion, deposition, adaptation as in the static beauty of its rings. Here, the geology lessons of deep time converge with ecology's story of survival and with human narratives of wonder and stewardship. As the embers glow, we feel united with explorers past ancient nomads guided by starlight, 19th century surveyors sketching ridges on parchment, modern scientists probing core sample sand. We realize that our own footsteps now become part of this landscape's vast tapestry. In the pale light of dawn, we set out along the western shoulder of the Eye, traversing gentle slopes where wind-blown dunes have collected against the ridges. Here, geomorphologists study the sand's grain-size distribution, using sieves and laser diffraction to discern how wind speeds and directions have shaped dune fields over time. They find that coarser grains accumulate at the base of the ridges, gradually building Barchan dunes that migrate slowly downwind. Tracking their movement with GPS stakes, they observe shifts of several meters per year, reminder that even seemingly immovable landforms are in constant flux. As the day warms, our path leads us to a series of rock shelters etched into the inner face of the middle ridge. Archaeologists kneel to examine charcoal stains and flake debris evidence of hearths and tool-making activities dating back thousands of years. Under UV light, the faint glow of phosphorescent residues highlights patterns of human occupation, roasting pits where meat was cooked, stone arrangements that might have held pots or supported shelters, and cupola small hemispherical hollows ground into the rock surface, perhaps used in ritual or as grinding depressions for pigments. Beneath these marks lies a palimpsest of human presence, layers of occupation and abandonment, settlement and flight, all set against the wider backdrop of shifting climates. Further into the gorge, rock art panels emerge, ochre-red depictions of cattle, giraffe, and human figures, their outlines rendered in bold strokes. These images, painted at different times by successive generations, trace a transition in artistic style and subject matter from the elegant, naturalistic forms of a lake-rich environment to more schematic depictions of nomadic life. In some panels, figures wear distinctive headdresses or carry curved swords, hinting at cultural shifts and the arrival of new peoples or technologies. Ethnohistorians interpret these motifs as markers of identity, linking them to ancestral Tuareg lineages and broader Saharan networks of trade and exchange. The art thus becomes not only a window into ancient ecosystems, but a record of human adaptation and social transformation over millennia. By late afternoon, we emerge from the canyon onto a broad terrace overlooking the inner basin. The shadows of the ridges lie cradled in the basin's embrace, and the low-angle light accentuates the intricate topography of sand drifts, pebble fields, and scattered vegetation. Botanists collect specimens of annual wildflower species that germinate and bloom briefly in the wake of rare rains, pressing them into herbarium sheets for later analysis. Their work reveals how the eye's microhabitats support distinct plant communities, some of which are found nowhere else on Earth. Conservationists hope that by cataloging this floral diversity, they can advocate for protections that extend beyond the geological park's boundaries to include surrounding dune ecosystems. As we make our way back to camp, the desert's temperature cools quickly, and the sky ignites in a palette of crimson and gold. We pause at the basin's center, where silence deepens and the enormity of the eye's story settles upon us. From Precambrian seas to Pleistocene lakes, from hunter-gatherers to modern scientists, from geological upheavals to fragile blooms, this place has witnessed the full sweep of Earth's drama. In its concentric rings lie the traces of ancient oceans, shifting climates, evolving life, and unfettered human imagination. And though the legend of Atlantis inspired our journey here, it is the eye's authentic narrative of continual change, resilience, and wonder that holds us wrapped. Under a vault of early evening stars, we gather once more to share reflections. The eye teaches us that the search for lost civilizations need not end in disappointment, for in uncovering the true story of this remarkable feature, we find a deeper connection to the continuous processes that shape our planet and, in turn, shape us. The eye of the Sahara, in all its geological, ecological, and cultural complexity, offers not a ruin of myth but a living testament to the intertwined saga of Earth and humanity. And as we extinguish our campfires for the night, we carry with us the echo of its concentric whispers, confident that, even in absence of Atlantean ruins, our quest has revealed something infinitely richer. Soft dawn light filters through high cirrus clouds, painting the eye's outer ridge in pale rose and lavender. Today, engineers and educators have arrived to inaugurate a virtual reality program designed to bring the Sahara's heart to classrooms across the globe. In a cleared area of the basin floor, they assemble sleek VR domes wired to generators and solar panels, each headset preloaded with a three-dimensional reconstruction of the eye through time. As participants slip on the headsets, they find themselves soaring over the basin in prehistoric epochs far above a sprawling paleo lake, its waters teeming with catfish and hippopotami, then drifting onward to witness the gradual retreat of the lake and the emergence of dunes that spiral like dragon whirls on the landscape. Within the dome, the concentric ridges appear interwoven with animated sediment layers, Bands of sandstone, shale, and limestone shift and fold in real time as tectonic forces mimic the rifting of Gondwana. When virtual rain falls into the basin, students see gully erosion carve channels, then deposit silty floodplains below. Meanwhile, pop-up annotations describe isotopic ratios, radiocarbon dates, and pollen assemblages gleaned from core samples, contextualizing each scene with scientific precision. Educators watch observers' gaze shift from macro-scale continental drift to micro-scale fossilized foraminifera, preserved in limestone, illustrating how Earth's vast processes interconnect across space and time. Outside the domes, archaeologists conduct experimental digs in simulated test pits, using trowels and brushes on exposed gravel and sand. Nearby, local nomadic guides demonstrate ancient flint knapping techniques, crafting microliths that echo those unearthed along the eye's flanks. Children from a boarding school in Nouakchott watch in fascination, learning not only about the geophysical past but also about the ancestral traditions carried by Fatimata's lineages of caravan journeys, folklore of water springs, and rites of passage under the ridges. As sun climbs higher, the hybrid camp of scientists, artists, and educators buzzes with activity, each group contributing to a shared narrative, one that fuses technological innovation with cultural heritage and ecological stewardship. By midday, a convoy of electric all-terrain vehicles arrives, carrying botanists and zoologists intent on cataloging the eye's remaining biodiversity. They disperse to microhabitats, mapped by drone service-ternary junctions, where perennial springs sustain tamarisk thickets, patches of cyanobacteria crust on the basin floor, and concealed crevices home to rare scorpion species. Using handheld spectrometers, they record spectral signatures of plant pigments and soil minerals, adding thousands of geotagged data points to an open-access database. This living atlas will inform conservation planning, guiding park rangers in establishing no-go zones around fragile sites and water sources critical to both wildlife and nomadic herders. In the glow of late afternoon, a team of climate modelers gathers at the field lab to integrate their thermal sensor data into regional climate projections. They observe that temperature inertia in the inner basin, combined with projected increases in monsoon variability, could intensify flash flood cycles and heat waves. By collaborating with Mauritanian meteorological agencies, they aim to develop early warning systems for nomadic communities, blending traditional weather lorisuck as reading cloud formations with satellite-derived precipitation forecasts. Such initiatives exemplify how understanding the eye's physical dynamics directly benefits human resilience in a landscape defined by extremes. As twilight descends, engineers test a network of low-powered LoRaWAN nodes deployed across the rim to relay environmental data in real time. Each node camouflaged against the sandstone monitors humidity, wind gusts, and seismic tremors, feeding into a cloud-based platform accessible to researchers worldwide. In the hushed light of dusk, this mesh of sensors transforms the eye into an open-air observatory, its concentric rings now conduits for continuous scientific inquiry. Under a vault of emerging stars, field teams convene to share insights about the VR program's pedagogical impact, the Atlas of Biodiversity, the climate risk maps, and recognize that the eye of the Sahara, once a silent monument, now pulses with data, knowledge, and community engagement as never before. Night's final luminescence fades, and the eye's ridges recede into silhouettes against a silver sky. In this tranquil pre-dawn hour, comparative geologists convene to place the eye within the broader tapestry of Earth's uplifted domes and eroded anticlines, from the Hanggai Mountains of Mongolia to the Richat structure of Mauritania's neighbor, the Tenere. Presentations contrast the eye's near-circular symmetry with the more irregular patterns of other structures, attributing differences to variations in lithology, tectonic stress orientation, and rainfall regimes. Yet despite these contrasts, all share a common story: sedimentary layers tilted by crustal forces, sculpted by erosion into features that captivate imaginations and challenge simplistic narratives. Amid technical discussions, philosophers and poets gather to reflect on what the eye symbolizes beyond geology. One speaker invokes the concept of the deep self, likening the concentric rings to layers of human consciousness surface impressions eroded away to reveal core truths, each stratum a memory or belief shaped by the currents of experience. Another offers a meditation on the eye as threshold, a liminal space where the known world meets the unknown, where science and myth converge in creative tension. Listeners, seated on mats beneath tamarisk branches, close their eyes and visualize the rings as pathways inward, guiding them through geological time toward introspection and wonder. At sunrise, the eye's full panorama emerges anew, its concentric arcs glowing in warm gold. In this final gathering, diverse voices, united geologists, ecologists, historians, educators, artists, each recounting what they have learned, that the eye is not Atlantis, yet is more powerful for what it truly is, that the concentric rings are chapters of Earth's biography, not engineered moats, that myths arise from human yearning, but facts endure through rock and sediment. They speak of future plans, a digital museum showcasing data and oral histories, cross-disciplinary fellowships to foster integrated research, community-led tours that honor both science and tradition. As the day rises fully, we stand at the heart of the eye one last time. Beneath our feet is the sum of eons, ancient oceans, monsoon floods, tectonic awakenings, human footsteps long since faded. Around us swirl dust devils and drifting sands, as if the desert itself breathes. In our minds, the legend of Atlantis yields to a deeper truth, that the true marvel lies not in lost empires, but in the Earth's capacity to write its own epic, concentric narrative of change, resilience, and beauty. And as we depart, each of us carries a piece of that epic within, a story etched in stone, alive in memory, and echoing in the rhythms of our own lives. Morning light spills across the basin floor as a gentle breeze stirs grains of sand into languid, dancing columns. Today, our journey carries us along the southern margin of the eye, where shallow terraces rise in gentle steps from the basin's heart. These terraces, remnants of ancient shorelines, mark successive high-water stands of the great paleo lakes that once filled the concentric rings. Underfoot, wind-polished cobbles ring with the hollow note of agate and jasper, carried downstream by rivers long vanished. Geologists kneel to log each stratum, measuring angle and thickness with precision, while geoarchaeologists sift through gravel lenses, searching for microliths and beads that speak to human presence at the water's edge. Here, at the interface of water and land, the story of adaptation unfolds. During humid phases, fish bones cluster in shell middens, mounds of discarded remains heaped by communities whose sustenance depended on the lake's bounty. Carbon-14 dating places these middens at roughly 80 years before present, coinciding with the African humid period's zenith. Ethnobotanists examined charcoal fragments, identifying charred seeds of wild millet and sorghum harvested from floodplain field sand pollen grains that hint at riparian woodlands of acacia and ebony. Such data weave a picture of a thriving landscape where humans cultivated wild resources, fished its waters, and lived in harmony with shifting margins. As the sun climbs, we reach a low promontory overlooking a shallow depression ringed by pale, salty flats. During wet episodes, this hollow brimmed with brackish water, a last vestige of the Paleolake, before aridity claimed the basin. Today, tottering halos of salt and gypsum trace its outline, and tufts of salt-tolerant shrubs dot the margins. Soil scientists scrape thin crusts of efflorescent minerals, analyzing the chemistry to reconstruct salinity curves over millennia. Their findings reveal cyclical pulses, phases when the lake concentrated to hypersaline lakes, killing off most life and depositing crystalline salts, interludes when fresh inflow revived ecosystems, allowing fish and waterfowl to return. In these oscillations lies a lesson for modern climate adaptation, reminder that ecosystems can recover if given sufficient water, but can equally collapse under prolonged stress. At midday, we descend to the basin floor where a group of artists from Nouakchott has set out canvases and pigments to capture the eye's chromatic wonders. They mix ochres gleaned from weathered sandstone, browns from desert clay, and the rare violet hues of manganese-tinted silt. Their paintings, large, abstracted swaths of concentric arcs reverberate with the palette of the landscape, each brushstroke an homage to time's slow palette. As they work, Fatimata recites a poem about the eye's silent rings of memory, weaving lines in Tamashek that evoke rippling waters, shifting sands, and the gaze of a world beyond human scales. Listeners close their eyes to feel the cadence, the words resonating with the wind's whisper through dunes. In the afternoon heat, we gather around a solar-powered lab where environmental engineers demonstrate a prototype desalination unit designed for desert springs. By harnessing the sun's energy, the unit distills brackish water into potable supplies, offering hope for nomadic communities whose groundwater has grown increasingly saline. Local elders discuss how such technology could stabilize water access without disrupting cultural patterns of seasonal migration. The engineers invite feedback, integrating traditional knowledge of spring locations and seasonal flow into their Desingson example of co-production that marries high technology with centuries-old wisdom. As dusk paints the ridges in dusky rows, we ascend the outer ring one last time. From this vantage, the concentric terraces below resemble the tiers of an amphitheater built by the ages themselves. The wind stirs, carrying the scent of warmed rock and distant myrrh-like resin from tamarisk blossoms. In this moment, we sense the full tapestry of the eye's narrative, the interplay of water and stone, of human ingenuity and geological time, of myth and science. As stars emerge overhead, the pale outline of Orion's belt hangs directly above the basin's center, a cosmic echo of the eye's concentric symmetry. And so we leave, footsteps retracing ancient routes, hearts imprinted with echoes of a world that once thrived here and may yet again. Pre-dawn chill holds the desert in an otherworldly hush. The lunar disk hangs low in the western sky, illuminating the concentric ridges with silvery relief. This hour belongs to the nocturnal life that stirs when sunbeams retreat. Biologists lie concealed by the rim's shadow, recording ultrasonic calls of bats as they swoop low over the basin floor in search of insects. Each bat's flight path, tracked by infrared cameras, maps invisible corridors between crevices and ephemeral water points. Early analyses reveal at least 7 distinct bat species here, some endemic to Mauritania's core desert's adaptations refined by millions of years of isolation. As dawn's rosy fingers appear, our convoy traverses the ridge's crest toward a narrow gap where a small cavern beckons. Speleologists ascend, exploring a chamber where the limestone roof yields to mineral deposits. Speleothem stalactites and stalagmites glimmer in the torchlight, their calcite layers recording drip rates that scientists will later correlate with past rainfall variability. On the cavern floor, ornithologists inspect nests of sand martins, their diminutive mud structures clinging precariously to overhanging ledges. These avian architects time their breeding to coincide with insect hatches after rare desert rains, linking avian life cycles to the eye's erratic moisture pulses. Mid-morning heat drives our party back into shaded gullies, where a team of hydrologists measures water chemistry of a small spring emerging at the base of the inner ring. Electrical conductivity meters reveal elevated salinity, while isotopic analyses of oxygen-18 and deuterium in the water point to mixed sources ancient groundwater recharged during the late Holocene humid phase, blended with modern rainfall infiltrating through fractured bedrock. These findings upend previous assumptions that the spring was entirely fossil water. Instead, it represents a dynamic aquifer responsive to episodic recharge. For local herders, this spring has been a critical lifeline for centuries, and understanding its recharge dynamics is key to sustainable management amid encroaching desertification. As the sun climbs higher, archaeobotanists gather in a sheltered alcove where pollen-rich deposits have survived millennia. By extracting cores from these paleochannels, they isolate grains of papyrus, sedges, and grasses, constructing a nuanced chronology of vegetation change. Their pollen diagrams illustrate a sweeping shift from papyrus-dominated wetlands to acacia and tamarisk groves, and finally to thorn scrub steppes. Intercalated charcoal layers signal episodes of human-set fires, perhaps to clear fields or drive game evidence of anthropogenic influence on the landscape dating back at least 50 years. These data underscore humans as active agents in ecosystem transformation, even in places we might assume untouched by culture. In late afternoon, a mobile 3D printing workshop anchors at a shaded alcove. Engineers demonstrate how sand from the eye's dunesrick in silica and calcium can be used as a feedstock for binder jet printing, producing scale models of the concentric ridges. Students watch as layer upon layer of sand is bound into a solid replica, then cured and polished. Such models provide tactile tools for education, enabling learners to feel the curvature of ridges and to visualize sedimentary layers. The project hints at a future where desert sands become not only a story of loss and erosion, but also of innovative material reuse. As twilight deepens, storytellers gather in a semicircle around a low flame. Elders recount tales of ancestral journeys of caravans that skirted the eye's fringes, of campsites where they first glimpsed its rings, and of nighttime rituals honoring the spirits believed to dwell beneath the stones. These oral histories, woven with poetic metaphors of riverstone rings and sky's reflection in sand, enrich our scientific understanding with layers of cultural meaning. In that interplay of data and dream, we recognize that the eye's full story emerges only when multiple voices, geologist, biologist, anthropologist, artist, elder, speak together under the vast desert sky. Dawn's golden glow bathes the eye as we prepare for a traverse across the basin flora journey that will take us from the inner ring to the outermost ridge in a single sweep. Our vehicles roll across the flat expanse, tires crunching on a pavement of desert pavement, microscopic stones fused by eons of wind erosion. Geotechnical engineers collect surface samples to assess load-bearing capacity, testing prospects for low-impact eco-lodges that could welcome future visitors without disturbing the fragile crust. Pilot tests of elevated walkways are underway, steel mesh platforms that hover above the soil, allowing tourists to traverse the basin while preserving its crust and microfauna. Mid-morning finds us encamped at a low dune formed where the prevailing northeasterly winds funnel between ridges. Landscape ecologists measure dune migration rates and vegetation encroachment, noting patches of pioneer grasses whose roots stabilize sand and foster microhabitats. These grasses trap moisture from nighttime condensation, nurturing nematodes and tardigrades that feed on bacterial mats, microscopic ecosystems hidden beneath our feet. By cataloging DNA from soil metagenomics, researchers aim to map the eye's cryptic biodiversity, revealing new species of extremophiles adapted to scorching heat and desiccation. As the sun peaks, heat radiates from pale clays in the basin's center, prompting a break for shade and hydration. Anthropologists use the pause to interview Tuareg guides about traditional resource management practices for locating new wells, rationing water during transit, and reading animal tracks to predict hidden springs. These techniques, honed over centuries of desert travel, inform contemporary water security projects and underscore the value of indigenous knowledge in confronting climate change. Meanwhile, geophysicists employ magnetometers to scan for buried paleochannel deposits, iron-rich sediments that could indicate former riverbeds. Their magnetic maps reveal anomalies aligning with core sample evidence of subsurface gravels, allowing the reconstruction of vanished waterways that once fed the eye's lakes. In the afternoon, our traverse reaches the outermost rim, where the elevation offers panoramic vistas of the namesake eye from above. Here, climatologists set up a portable LiDAR unit to measure albedo differences between ridge slopes and basin flats. Their findings will refine climate model inputs for surface reflectivity, crucial for predicting energy budgets in arid regions. Photographers capture time-lapse footage of shadows creeping inward across the rings, akin to the hands of a cosmic clock marking geologic epochs in minutes. As twilight cools the air, we gather for a final reflection at the rim's crest. The concentric rings lie below like ripples on a pond frozen in stone. In their form, we see the imprint of tectonic uplift, the sculpting hand of wind and water, the imprint left by creatures great and small, the footsteps of human wanderers, and the whisper of dreams, whether of Atlantis or of future generations, who will continue to explore and protect this remarkable place. In that moment, the eye reveals its ultimate lesson, that true wonder arises not from finding mythic cities, but from witnessing the ongoing dialogue between Earth's physical forces and the lives they sustain. Under the vault of emerging stars, we depart silently, carrying with us the concentric story of stone, sand, life, and imagination, an epic as enduring as the sands themselves. Pale golden light filters across the basin floor as dawn breaks over the eye's southernmost ridge. Today's focus is on the dynamics of desertification and renewal, where the most recent satellite imagery reveals subtle shifts in dune migration patterns. Remote sensing specialists converge on a temporary command tent, their computer screens alive with color-coded overlays, showing sand encroaching upon the inner rings over the past decade. Using high-resolution interferometric synthetic aperture radar, INSAR, they have detected vertical displacements of mere millimeter-small but significant flexures in the ancient anticline that hint at deeply buried fault strands releasing stress beneath. These measurements, when combined with ground truth from GPS benchmarks embedded in compacted ridges, offer a precise chronology of how tectonic quiescence and wind erosion conspire to reshape the eye at granular timescales. Beyond the geophysics, ecologists venture along the marginal escarpments, where the plant community transitions abruptly from thorn scrub to open desert pavement. Here, systematic transects record species, richness, and cover, documenting how resilient shrubs like zygophyllum and Anastatica hyrochontica leverage deep taproots and desiccation-tolerant seeds to colonize freshly scoured soils. Their presence stabilizes microdunes and creates microsite test-shaded, moisture-retentive pockets where other, more delicate flora can germinate after rare rainfall. Soil ecologists corral samples for DNA metabarcoding, aiming to tease apart the fungal and bacterial consortia that underpin nutrient cycling in this hyper-arid environment. Preliminary results suggest novel extremophile communities thriving on mineral films at the air-rock interface, organisms whose metabolic pathways could inspire biomimetic innovations in water harvesting technologies. Mid-morning, the camp's soundscape quiets as a team of glaciologists turned paleoclimatologists assemble to repurpose ice core analysis methods on hard carbonate nodules collected from the inner ring's playa margins. By drilling centimeter-scale cores into these concretions, they reveal alternating laminations of calcite and aragonite, each band a snapshot of fluctuation between wet and dry seasons. Trace element ratios of strontium and magnesium within the bands speak to variations in groundwater chemistry, correlating with monsoon intensity peaks reconstructed from marine sediment cores off West Africa. This cross-disciplinary approach weaves the eye's paleoclimate record into global climate narratives, linking Sahara humid intervals to Holocene sea surface temperature anomalies and North Atlantic storm tracks. As the sun climbs, attention turns to the human dimension, A delegation of Mauritanian heritage officers meets with surveyors to finalize the boundaries of the newly designated geological park. They discuss zoning that balances open access trails for ecotourists with strictly protected research areas. Local herders contribute oral maps routes they traverse seasonally that intersect the eye's periphery, ensuring that neither livestock corridors nor ancestral gravesites are inadvertently compromised. In a gesture of reciprocal stewardship, the heritage officers have delivered satellite-enabled radios to nomadic families, enhancing their link to weather forecasts and park management staff. This co-management model stands as a blueprint for integrating indigenous land use with scientific conservation. By afternoon, drones hover over a series of shallow pools clustered along the inner ring's fracture lines. Limnologists collect plankton and microbial mat samples, discovering phototrophic bacteria forming laminated stromatolite-like biofilms. These living analogs to some of Earth's oldest fossils underscore the eye's capacity to host relict ecosystems, microbial time capsules that persist in isolated niches. The researchers speculate on the analogies to Martian paleolakes visible in orbital imagery, positing that these biofilms could guide astrobiological investigations of extraterrestrial sedimentary basins. In this way, the eye's concentric rings resonate far beyond terrestrial science, informing questions of life's resilience on other worlds. As dusk deepens into night, field teams convene at a cluster of solar-powered lanterns. Conversations weave between seismic tremors, bacterial genomes, community mapping, and astrobiological prospects. Above, the Milky Way arches in celestial splendor. Here at the nexus of disciplines, the eye of the Sahara stands as more than a geological wonder. It is an incubator of knowledge, a crucible where ancient processes and modern innovation converge to expand our understanding of Earth and, perhaps, of worlds beyond. Pale dawn light glows around the edges of the eye as virtual reality filmmakers and sound designers arrive to capture the gentle hum of the desert waking. They set up stereoscopic cameras on the upper slopes to record the shifting interplay of light and shadow across the ridges, and hydrophone-like mics in the basin to record the barely audible crack of cooling rock. The resulting footage, the centerpiece of an immersive documentary, will marry panoramic visuals with an enveloping oral landscape, whispered winds, distant bat calls, the low rumble of subterranean tremorsto create a cinematic sense of place that transports viewers into the eye's silent heart. Nearby, a group of multidisciplinary interns test a portable mixed reality station that overlays geologic maps onto the landscape as users scan the horizon with AR goggles. As one intern pans the view, the goggles render a transparent overlay of buried stratigraphic lines and fault traces, while text boxes annotate key features: Jurassic sandstones, 100–8200 Ma, anticlinal axis, ancient lake margin. Field instructors watch students navigate these overlays, evaluating how augmented data enhances spatial understanding of the eye's three-dimensional architecture. Initial surveys show increased retention of geologic principles and stronger intuitive grasp of structural geology among participants. By midday, an art residency cohort sets up a mobile kiln at the basin's center, using clay collected from playa sediments to craft vessels that evoke the eye's concentric motif. Firing them in solar ovens that harness parabolic reflectors, the artists fuse sand, pigment, and organic inclusions, camel hair, acacia resin into ceramic forms that bear the material memory of their source. These vessels, intended for a traveling exhibition, embody a dialogue between geology and human creativity, each a small artifact of place, shaped by the desert's elemental forces. In the early afternoon, film crews descend into a narrow canyon to document a local griot reciting genealogies beneath a tamarisk. Her voice, low and resonant, weaves ancestral lineages through the ringing of stone upon stone, her rhythmic patter echoing the eye's concentric harmony. The camera circles her as she invokes the spirits of wind and water, recounting how her forebears once navigated these ridges by mnemonic chants tied to rock formations. These oral narratives, captured in high-definition audio, will become an interactive layer in the eye's digital archive, preserving intangible heritage alongside sediment cores and drone footage. As the sun dips low, climate scientists convene a workshop in the largest tent, presenting integrated models that couple groundwater recharge simulations with socio-economic projections for nearby villages. They demonstrate a decision support tool that maps optimal borehole locations to maximize access while minimizing drawdown impacts on springs feeding the inner rings. Local council members test the interface, adjusting rainfall scenarios and observing aquifer responses in simulated real time. This co-development of tools underscores the eye's role as a living laboratory for sustainable resource management in arid lands. At twilight, editors assemble in a makeshift screening room carved from shade cloth, previewing rough cuts of VR sequences, AR overlays, and documentary segments. They debate pacing, whether to linger on the slow dwell of wind on stone or to accelerate through sequences of seismic data visualizations. Outside, the sky dims to deep indigo and the first stars wink into view. In this convergence of art, science, and technology, the eye of the Sahara continues to reveal new dimensions, reminding us that even the oldest rocks can inspire innovative ways of seeing and knowing our world. Early morning finds the concentric ridges bathed in rose-tinged light, and today's task is a comparative expedition beyond the eye to similar eroded uplifts on other continents. A team boards a satellite-linked video uplink to present a live webinar, connecting researchers in Mauritania with colleagues at the Richat structure in neighboring Algeria and the Glass Buttes in Oregon, USA. Each site, though distinct in scale and composition, shares hallmarks of circular stratigraphy carved by erosion. Participants exchange time-lapse videos of erosion gullies, spectroscopic scans of mineral suites, and 3D models of fracture networks. This global dialogue fosters a synthesis of regional tectonic histories, illuminating how intracontinental rifting and subsequent erosion produce architectural analogs across disparate environments. Meanwhile, local school teachers lead field trips for secondary students, guiding them through interactive stations illustrating the eye's formation. At one station, students hurl colored pellets down a tilted sandbox to mimic tilted sediment layers. At another, they baptize synthetic soil profiles in dyed water to observe infiltration. They record observations in field notebooks, sketching the ridges and noting foliation angles. Their giggles echo against the stone walls, as they discover geology is not only rocks in textbooks, but a tangible, hands-on adventure unfolding beneath the vast sky. By midday, a team of astrophysicists returns to capture solar transit shadows passing over the ridges. Using solar telescopes and pinhole cameras, they trace the path of the sun's disk across different rings, calculating precise latitude and longitude based on shadow angles. This data feeds into a geoastronomical model that reconstructs how ancient observers might have used the eye's geometry as a rough sundial, marking solstice sunrises with light streaming into shallow alcoves. Such hypotheses bridge archaeoastronomy and vernacular traditions, suggesting that even without formal structures, nomadic peoples could harness the landscape's natural geometry to track time. In the afternoon heat, hydrologists revisit the inner ring springs to deploy pressure transducers that record minute fluctuations in water table height. The sensors capture diurnal cycles influenced by atmospheric pressure shifts and nocturnal cooling, revealing a complex interplay of barometric pumping and fracture flow. These insights refine conceptual models of the eye's aquifer, clarifying how ephemeral recharge events propagate through the fractured anticline to sustain perennial springs. For water managers, such granular understanding informs equitable allocation strategies during drought, safeguarding both human and ecological needs. As the sun descends, community leaders inaugurate a trail of time, walking path along a segment of the middle ridge. Signage crafted from locally sourced wood describes geological periods, ecological zones, and cultural milestones as walkers progress through space and deep time. Elder Fatimata leads the inaugural walk, reciting ancient verses at each marker, her voice rising and falling like the concentric arcs beneath our feet. Children skip ahead, pointing out fossil fragments embedded in stone, while scientists pause to demonstrate rock typing and core sampling techniques. In this integrative ritual, the eye's story becomes a shared heritage parade where every step we take echoes with the layers of Earth's biography and the voices of those who call this place home. Under a final canopy of stars, we reflect on the journey so far. 25 parts of an unfolding narrative that began with whispered myths of Atlantis and evolved into a living tapestry of geology, ecology, culture, and innovation. The eye of the Sahara, once a mysterious bullseye in the desert, now stands as a beacon of interdisciplinary discovery, a reminder that the greatest treasures lie not in hidden palaces, but in the concentric interplay of stone, sand, life, and human imagination. Pale dawn light bathes the eye's outer slope in a gentle gold, and today, our focus shifts to biogeography, the ways in which life has colonized and retreated from this concentric arena. Ecologists fan out along a transect from the basin center to the rim, recording shifts in species composition every half kilometer. At the inner basin, communities of cyanobacteria and halophilic algae coat the surface of ephemeral ponds, their glistening mats of vibrant green against pale clay. Farther along, saltbush and tamarisk form low, tangled thickets on the inner ring slopes, while the middle ridge supports drought-adapted grasses, whose seed heads sway like golden embers in the breeze. At the outermost ring, thorn scrub gives way to open gravel plains, dotted with spiky succulents. In each zone, researchers collect specimens, noting morphological adaptation succulents, reflective leaf coatings, deep taproots that enable survival in extremes of heat, salinity, and desiccation. Their data will feed into models predicting how climatic shifts may reconfigure these communities in the coming centuries. As the sun climbs, a contingent of ornithologists arrives, setting up mist nets among tamarisk stands to capture and ban desert birds. They gently disentangle wheatears, larks, and finches, measuring wing lengths and fat reserves before releasing them. Their preliminary ringing data show that some individuals are continental travelers, pausing at the eye's watery flecks on journeys between Europe and sub-Saharan Africa. Others appear resident, nesting in crevices along the ridges, and timing their breeding to coincide with the rare bloom of desert wildflowers. These observations underscore the eye's role as both oasis and thoroughfare node in migratory networks that link distant ecosystems. By midday, herpetologists gather at a small alcove where a trickle of groundwater sustains a patch of green. Here, they survey reptiles and amphibians, spiny-tailed lizards basking on sun-warm rocks, geckos darting among fissures, and the occasional desert frog that emerges briefly after rains. Using pitfall traps and visual encounter surveys, they document species richness and abundance, tagging individual lizards with tiny, numbered paint dots. Their research illuminates how temperature differentials between shaded canyons and open ridges create microclimates that these ectotherms exploit pockets of cooler refuge during scorching midday heat and warmer perches to absorb solar radiation at dawn. In the afternoon, entomologists fan out with aspirators and sweep nets, collecting insects drawn to the fragile blossoms of desert annuals. They find ghost moths with translucent wings that seem to vanish against the sky, jewel-like beetles that reflect turquoise in the sun, and solitary bees that burrow in sandy flats. Each specimen is pinned, labeled with GPS coordinates, and sent for DNA barcoding. Their findings promise to fill gaps in our understanding of Sahara insect biodiversity critical baseline data in an era of accelerating environmental change. As dusk falls, all teams reconvene at the basin's central campfire. Under a canopy of stars, they share tales of discoveries big and small. A rare plant found only on the southern flank, a new range record for a migratory warbler, the first record of a burrowing scorpion sensitive to moonlight. In their voices is the exhilaration of having mapped life's tenacity, where few had ventured before, and the recognition that the eye's concentric geography has shaped ecological patterns as much as geology. The night's calm settles in, and we realize that the story of the eye is both natural history and living laboratory narrative written in every petal, scale, and wingbeat. A rosy pre-dawn glow precedes our departure toward a remote saddle between the middle and outer Ringza, favored spot for radar surveys, because its relief is minimal and its surface stable. Geophysicists deploy ground-penetrating radar, GPR units, scanning in parallel transects to map subsurface layering down to depths of several meters. As the radar pulses drift through sand and rock, the data reveal faint reflections, paleolacustrine deposits now buried beneath wind-blown sheets, lenses of gravel marking ancient river channels, and subtle fault offsets that hint at tectonic nuances beyond the simple domed structure. These profiles, once processed, will allow reconstruction of the eye's sedimentary history in 3 dimensions, clarifying how pulses of deposition and erosion sculpted the concentric architecture we see today. Meanwhile, geochemists collect rock samples from each visible layer: sandstone, siltstone, limestone, gypsum, and pack them for laboratory analyses. Back in the university's mass spectrometer suite, these samples will be probed for rare earth element concentrations, stable isotope ratios, and trace mineral inclusions that fingerprint provenance, depositional environment, and diagenetic alteration. Together, GPR data and geochemical signatures promise a high-resolution chronology, linking each ridge's formation to specific episodes of climatic change and tectonic activity. At midday, a team of paleoanthropologists investigates a rocky overhang halfway up the middle ridge, where lithic scatters hint at repeated use by early human groups. Carefully excavating a small trench, they uncover microlithic points, grinding stones, and the fragmented remains of ochre-painted ceramics. Radiocarbon assays of charcoal from a hearth pit date the occupation to roughly 500 years ago, coincident with one of the African humid period's wet phases. Use-wear analysis on the tools suggests they were used for fish processing and plant harvesting, reflecting a mixed foraging strategy that capitalized on the eye's transient resources. These findings contribute to broader debates on how environment shaped subsistence and mobility among Sahara hunter-gatherers. By mid-afternoon, climate modelers convened for a hybrid workshop, half in the field camp, half dialing in virtually from climate centers. They integrate meteorological station data collected over the past year: temperature, humidity, wind speed with regional circulation models to simulate future precipitation patterns around the eye. Scenarios range from continuation of gradual aridification to intermittent pulses of enhanced monsoonal activity. Participants discuss adaptation strategies, water harvesting, drought-tolerant fodder crops for pastoralists, early warning systems for extreme heat events. The dialogue underscores the eye's dual identity as both ancient wonder and sentinel for contemporary climate challenges. As twilight deepens, artists return to their easels, capturing this convergence of science and landscape in bold strokes. Their canvases depict researchers juxtaposed against the eye's rings, tools, and instruments nestled among rock strata, a human narrative woven into the tapestry of deep time. And as the night sky blossoms overhead, we gather once more to reflect that the eye of the Sahara remains a nexus where geology, ecology, archaeology, and culture intersect, a place where each discovery begets new questions, and every ridge, every organism, every artifact resonates with the concentric echoes of Earth's unfolding story. Pre-dawn mist is rare in the Sahara, but today a thin veil of airborne dust refracts the sunrise into soft pastel bands, lending the eye an ethereal quality. Botanists seize the morning calm to revisit a small stand of ephemeral wildflowers discovered after recent rains. They set up quadrat sown meter square sand count individual plants by species, recording phenological stages from bud to bloom to seed set. Their observations reveal a succession. Mat, forming species germinate first, stabilizing soils and creating microhabitats, followed by taller annuals that flower and set seed within a few weeks. This boom and bust cycle compresses an entire plant life cycle into a fleeting desert momenta testament to life's improvisational resilience. North of the basin, soil scientists examine crustal morphology, hard, varnished surfaces of desert pavement, where fine particles have blown away, leaving closely packed pebbles interlocked like ancient cobblestones. They probe beneath the pavement, finding a pavement table several centimeters thick, beneath which lies a layer of pebbles cemented by salts and biological films. Microbial ecologists sample these subsurface veneers, isolating extremophiles that harness scant moisture and feed on mineral substrates. Genetic sequencing reveals genes coding for novel proteins that protect cell structures under extreme desiccation, biochemical strategies that may inform development of drought-resistant crops or biomaterials. By late morning, a convoy of conservationists and community representatives convenes at a cluster of tamarisk around the Inner Ring Spring. They discuss a proposed management plan for Grazinga seasonal rotational system that ensures herds do not overexploit sensitive vegetation or contaminate water sources. Using GPS-tracked collars on camels, they have mapped winter and summer grazing zones, correlating animal movements with plant phenology. The resulting plan designates core conservation areas, buffer zones, and transhumance corridors, integrating nomadic traditions with ecological data. In a symbolic gesture, elders plant a tamarisk sapling act of commitment to sustaining both people and place. In the afternoon heat, remote sensing teams launch multi-rotor drones equipped with multispectral cameras, capturing data on surface reflectance across ultraviolet, visible, and near-infrared bands. These flights produce Vegetation Indices Normalized Difference Vegetation Index, NDVI, maps that highlight photosynthetically active areas, even in sparse desert flora. By comparing these maps over time, researchers track growth pulses, stress periods, and long-term trends in plant cover. Such data are crucial for adaptive management, alerting authorities to areas showing early signs of desertification or recovery. As twilight falls, the camp transforms into a classroom for local youth, invited by field educators to explore hands-on science. Children peer through microscopes at soil crust fragments, identify insect specimens pinned on entomology boards, and assemble simple weather stations that measure wind speed and temperature. Their laughter and curiosity underscore the eye's potential as an outdoor laboratory not just for seasoned experts, but for the next generation of desert stewards. In that moment, we realize that the eye's concentric story is still unfolding, written by researchers, community members, and young minds whose footsteps will trace these ridges long after we depart. A rosy glow tints the eastern horizon as a multidisciplinary team prepares to document the eye's acoustic environment. Bioacousticians distribute autonomous recording units among the ridge's devices that will log soundscapes continuously for weeks. As the team hikes to deploy the units, they pause to record live sound, the scrape of wind over sand, the drone of distant Forks 4 engines on gravel tracks, the echoing call of a francolin at daybreak. These recordings will help distinguish natural sound signatures from human disturbances, informing management plans to minimize noise pollution in protected zones. The contrast between the hush of true wilderness and the encroaching hum of vehicles highlights the delicate balance between access and preservation. Mid-morning, a group of structural geologists examines small, brittle faults that transect the inner ring's limestone beds. Using compasses and calipers, they measure fault strike and dip, noting slickened side-polished fault surfaces indicating past movement. Samples of fault gouge, the pulverized rock in the fault core, are collected for microstructural analysis back in the lab, where thin sections will reveal deformation mechanisms under polarized light. These studies refine tectonic models, showing that the eye's dome exhibits distributed fracturing rather than a single coherent anticlinal complexity that may explain patterns of erosion and sediment routing. By midday, climatologists visit the remote meteorological station established on the middle ridge, downloading months of data, diurnal temperature ranges of more than 30 degrees Celsius, wind roses indicating predominant easterly gusts, and rare precipitation measurements captured by tipping bucket rain gauges. They integrate these empirical records with reanalysis data to validate regional climate models, improving predictions of extreme heat and convective storm events. Such validations are crucial, as local stakeholders increasingly rely on accurate forecasts for water and livestock management. In the afternoon, ethnomusicologists gather beneath a tamarisk grove to record traditional Tuareg music. A band of griot musicians plays the imzadboud luteyand, the tendedrum, made of mortar accompanying poetic lyrics, recounting the eye's concentric rings as metaphors for genealogies and journeys. High-fidelity recordings capture the subtle overtones and rhythmic complexities, preserving an intangible cultural heritage intimately tied to landscape. These audio archives will complement geological and ecological datasets, ensuring that the eye's story remains holistic, honoring both natural and human voices. As the sun sets, a final symposium convenes under the stars. Each team presents a key insight: acoustic profiles to guide quiet zones, fault analyses refining erosion models, climate records enhancing forecasts, music recordings enriching cultural archives. In their convergence lies the essence of the eye's narrative, an ever-expanding tapestry woven from stone, soil, life, and song. And as the night air cools, we understand that while Atlantis may forever remain a myth, the eye of the Sahara stands as a living testament to Earth's capacity to shape worlds and inspire wonder in the endless concentric circles of time. Morning mist is replaced by a clear blue sky as we embark on an ambitious traverse of the eye's perimeter, covering over 300 kilometers of concentric ridge crest in a single day. Teams of geologists, ecologists, and photographers leapfrog in four-wheel drive vehicles, stopping at predetermined waypoints to collect rock, soil, and biological samples. At each point, GPS coordinates are logged, panoramic photographs taken, and brief observations recorded in field journals. The logistical choreography is delicate refueling vehicles at solar-powered pumps, coordinating satellite phone check-ins, and ensuring minimal disturbance to the fragile pavement beneath. At waypoint 15, geologists note a striking breccia layer-angular fragments of limestone, cemented by iron oxide matrix embedded within the middle ridge. Petrographic analysis later reveals that this layer originated from episodic mass-wasting events when heavy rains triggered slope failures on the uplifted dome. Such debris flow deposits punctuate the long-term erosion record with sudden, high-energy events, reminding us that desert geomorphology is governed by both gradual winds and rare but violent storms. By midday, ecologists document a transition in the outer ridge's flora from scrub and grasses to near-barren plains punctuated by lichens. Using quadrats and line transects, they quantify lichen cover and identify species adapted to extreme UV exposure and high thermal stress. These lichens act as bioindicators of air quality and microclimatic conditions, their presence or absence reflecting subtle changes in environmental parameters. Their surveys will inform long-term monitoring of ecosystem health in the geological park. In the afternoon, a photogrammetry team orchestrates a synchronized drone flight along the ridge crest, using overlapping images to generate a high-resolution digital elevation model, DEM. These orthophotos and 3D meshes will feed into an interactive web GIS, allowing virtual exploration of the eye's perimeter, complete with embedded datasets for each sampling point. Users anywhere in the world will be able to walk the ridges, examine core logs, and listen to ambient soundscapes recorded at those locations. This digital twin promises to democratize access to the eye's wonders while minimizing physical impact on the landscape. As the sun dips low, we converge at the southwest high point of the outer ring. From this vantage, the concentric curves stretch before us like ripples in stone, each ridge a threshold between past and present, each gully a passage through which water once surged, life once flourished, and humans once wandered. Around us, research vehicles idled, sampling equipment packed, drone batteries charging for the final flight. In the tranquil glow of dusk, we realize that today's traverse has not only mapped the eye's perimeter, but also cemented the collaborative spirit that drives its exploration. The concentric rings, once thought to conceal Atlantis, have instead revealed an endless spiral of discovery where each return to the center yields new insights, and every journey around the rim forges fresh connections between science, culture, and imagination. In that moment, the eye of the Sahara stands not as a silent ruin, but as a vibrant, living narrative, its concentric story continuing in the footsteps of every explorer who dares to listen. Soft pre-dawn light washes the concentric ridges in a muted glow, and today's expedition undertakes a survey of the eye's subterranean architecture. Geophysicists and speleologists collaborate to deploy a series of microseismic sensors in shallow boreholes drilled along an easterly transect of the inner ring. Each sensora, slender fiber optic cable coated in protective casing rests at depths of 10 to 15 meters, poised to record minute tremors generated by natural thermal fracturing, wind-induced stress release, and the distant rumble of sand avalanche events along the ridge flanks. Over the coming months, data streams will reveal patterns of rock fatigue, mapping zones of differential strain that hint at unseen fault strands, and pocketed voids left by ancient dissolution of soluble layers. Meanwhile, a team of hydrogeologists descends into a recently exposed gully where intermittent spring flow emerges from a fracture intersection. They install pressure transducers and temperature loggers, wrapping the sensors in insulated jackets to prevent diurnal thermal fluctuation from skewing readings. Water samples are collected in sterile vials, preserved on ice for later stable isotope ratio mass spectrometry, which will distinguish contributions of modern rainfall recharge from Pleistocene groundwater. Preliminary in-field test measuring conductivity, pH, and dissolved oxygen indicate a surprising level of microbial activity in the aquifer, with colony-forming units exceeding expectations for a system thought long isolated. Genetic sequencing planned at the home laboratory may uncover novel extremophilic taxa, reshaping our understanding of subterranean life in hyper-arid environments. At midday, archaeobotanists set up a flotation station near a cluster of small depressions, once thought to be simple windscour pits. By agitating soil samples in water, they recover charred seeds, pollen grains, and fragments of sedge roots that reveal a surprising diversity of wetland flora during mid-Holocene humid phases. Among the detritus lie microscopic fragments of papyrus, suggesting that stands of cyperus papyrus once fringed these oases, providing both raw materials for mat weaving and nutritious tubers for human and faunal consumption. Radiocarbon dating of the seeds places their deposition between 6,200 and 5,800 years ago, a critical window when the Sahara underwent abrupt aridification, driving both vegetational collapse and human migration to more hospitable corridors. In the afternoon heat, paleoecologists traverse the dune fields, marking the transition between the middle and outer ridges. They extract sediment cores via a hand auger apparatus, retrieving laminated sequences of wind-blown silt and sand. Under a portable shelter, they split the cores, allowing light to reveal delicate pollen bands and discrete layers of wind-rippled laminations. Each stratum becomes a proxy for past wind regimes, finer silts indicating low-velocity dustfall during hyper-arid intervals, coarser sands marking episodic high-energy events when supercell thunderstorms ejected sand grains onto the ridges. By correlating these cores with published paleoclimate records from the West African monsoon domain, they reconstruct a finely resolved climate chronology that underscores the eye's role as both a recorder and interpreter of long-term environmental change. As dusk falls, multidisciplinary teams converge at the basin's heart for a ritual of reflection. Geophysicists share early seismic profiles, revealing a surprising shallow anticline cusp near one of the springs. Hydrobiologists recount discovery of anaerobic microbes thriving in the aquifer. Archaeobotanists unveil microphotographs of charred papyrus fibers. Paleoecologists map a century of dune field migration. Each revelation weaves into the concentric tapestry of the eye's story where subsurface structures, living organisms, and human ingenuity converge. Beneath an emerging canopy of stars, we recognize that the eye's greatest secret is not the existence of hidden empires, but the dynamic interplay of Earth's processes and life's tenacity, unfolding in quiet drama beneath shifting sands. The morning sun glances off the polished sandstone of the middle ridge as our convoy ascends to conduct thermal infrared imaging of the eye's surface. Remote sensing specialists station a tripod-mounted thermal camera array, calibrating against rock thermistors embedded at varying depths. The resulting thermal maps, captured every 5 minutes throughout the day, will quantify heat retention differentials between lithology's quartz-rich layers that heat rapidly and cool quickly versus clay-rich strata that exhibit slower thermal response. Early data reveal pronounced heat islands along the inner ring's gypsum-cemented lenses, where trapped moisture fosters microbial biofilms that alter emissivity characteristics. These biofilms, detectable via thermal anomalies, may serve as proxies for mapping concealed water pathways and predicting spring locations. Simultaneously, soil ecologists collect surface crust samples from the basin floor, aiming to characterize the desert pavement's biological soil crust, BSC, communities. Under magnification in a shaded tent, they identify cyanobacteria, green algae, lichen, and moss spores, interwoven with mineral grain siege taxon, contributing to soil cohesion and fertility. Experimental plots are established to test recovery rates of disturbed crusts. Small quadrats are gently scraped, then periodically irrigated to simulate rare precipitation events. Photographs and chlorophyll fluorescence measurements track recolonization, offering insights into ecosystem resilience and informing guidelines for low-impact trail designation in the future geological park. At high noon, an interdisciplinary workshop convenes under canvas, juxtaposing traditional knowledge with empirical findings. Fatimata recounts oral histories of water harvesting technique stone contours that channeled scant rainfall into subsurface catchments, while geohydrologists overlay satellite-derived catchment delineations on a topographic model. Together, they plan experiments to recreate ancient cisterns using locally sourced stone veneer and gypsum mortar, testing their efficacy in capturing dew and rare drizzle. The workshop epitomizes co-production of knowledge, practitioners and scientists innovating jointly to address modern water scarcity challenges, rooted in ancestral ingenuity. By afternoon, drone-borne LiDAR surveys sweep the outer ridge's escarpment, generating point clouds with sub-decimeter accuracy. From these data, geomorphologists extract slope gradients, ridge curvature, and microtopographic indices that feed into erosion risk models. Projections suggest that climate change, induced increases in convective storm intensity, could accelerate gully incision rates by up to 15% over the next half-century, potentially compromising heritage sites and delicate BSC zones. Armed with these projections, park managers draft erosion mitigation strategies, planting salt-tolerant shrubs at vulnerable locations and constructing low-profile check dams to slow runoff velocities. As the sun dips, all teams gather at the basin's lowest point for a collaborative debrief. Thermal maps are projected against pollen diagrams. Soil crust recovery curves complement hydrological recharge estimates. Ancestral water harvesting designs inspire prototypes slated for field testing. In the soft glow of lanterns, we acknowledge that the eye's concentric story persists not only in stone and sand, but in the shared endeavor of people working together, melding ancient wisdom with cutting-edge science to steward this remarkable landscape through the uncertainties of the future. Dawn's pastel palette heralds an ambitious field day, a transect spanning from the inland edge of the basin's playa to the summit ridge, focused on characterizing nutrient cycling in this desert ecosystem. Biogeochemists set up a series of passive ion exchange resin probes at depths of 5, 10, and 20 centimeters, capturing soluble ions nitrate, phosphate, sulfate mobilized by episodic wetting events. The probes, retrieved after simulated rainfall applications, will reveal pulses of nutrient availability that sustain ephemeral plant communities following rare downpours. Preliminary in-field colorimetric tests hint at unexpectedly elevated nitrate concentrations, perhaps derived from bird droppings at seasonal roosting sites or microbial nitrogen fixation within BSC patches. Simultaneously, vegetation ecologists establish litter decomposition experiments. They deploy litter bags, fine mesh sacks, containing standardized masses of ground tamarisk leaves and grass clippings at multiple microsites, shaded canyon walls, exposed ridgetops, and saline flats. Retrieved at monthly intervals, the bags will be weighed to assess mass loss rates, with subsequent laboratory analyses determining changes in carbon to nitrogen ratios and lignin content. These data will elucidate the mechanistic underpinnings of organic matter turnover in an environment long considered nutrient-poor, challenging assumptions about desert ecosystem functioning. At high sun, a geology team undertakes X-ray fluorescence, XRF, scanning of hand samples from the inner ridge crest, measuring trace element abundance as strontium, zirconium, manganese that fingerprint, provenance, and diagenetic history. Coupled with petrographic thin section analysis, they discern subtle variations in cement composition, gypsum pockets enriched in rare earth elements, iron oxide bands marking paleo-seep activity, and dispersed organic carbon fragments suggesting dispersed algal mats in the basin's paleo-environment. Each sample becomes a microcosm of the eye's deep-time sedimentary drama, its elemental signature, a chapter in a protracted story of sea level oscillation and evaporative concentration. Mid-afternoon, archaeologists revisit a rock shelter on the southern flank, where previous excavations uncovered beads fashioned from ostrich eggshell. New excavations, constrained by rigorous stratigraphic controls, reveal a contiguous midden layer rich in snail shells and small vertebrate bones, perhaps the dietary refuse of children's foraging activities. Micromorphological sampling of the sediments will reveal trampling surfaces and micro-charcoal flecks, offering a high-resolution record of human occupation intensity and site use over centuries. As dusk approaches, teams reconvene beneath the open sky to present preliminary findings. Ion exchange resin data juxtaposed with litter decomposition curves. XRF elemental maps align with paleobotanical reconstructions. Midden excavations frame human-environment interactions in a new light. Together, these insights underscore the eye's complexity, not merely concentric rings of eroded rock, but an active laboratory of nutrient fluxes, biotic adaptation, and human resilience. In that closing hour, the eye of the Sahara affirms its place as a nexus of discovery, inviting each generation to unravel its myriad stories, layer by concentric layer. The first glow of morning touches the outermost ridge as a contingent of planetary scientists arrives to draw parallels between the eye and similar circular features on Mars. Using high-resolution satellite imagery and field observations, they compare the eye's lithological layering and erosion patterns with Martian craters, partially filled and exhumed by aeolian processes. Back at base camp, they run GIS overlays that align the eye's concentric rings with the rings world of Mars's Arabia Terra, hypothesizing that wind-sculpted crater rims on Mars may follow comparable degradation pathways to those in Mauritania. These analog studies inform rover mission planning, guiding site selection for sampling layered deposits believed to preserve ancient habitable environments on the Red Planet. Meanwhile, a symphony of hammers and chisels echoes along a vertical escarpment of fossiliferous limestone, where paleontologists extract specimens of freshwater mollusks and fish vertebrae. In a makeshift field lab, they clean and catalog each find, photographing shells with scale bars and documenting their stratigraphic position. These fossils, dated via uranium series analysis, provide direct evidence of Bayesian-filling episodes and, by extension, the timing and magnitude of African humid period pulses. Their presence cements the link between orbital forcing, monsoon strength, and the hydrological history imprinted in the eye's sediments. By midday, cultural anthropologists convene an impromptu gathering of local artisan weavers. On handlooms set up beneath acacia trees, they demonstrate traditional patterns inspired by the eye's ring's concentric bands of dyed wool, weaving together geometric motifs that echo the landscape's natural architecture. The resulting textiles, adorned with symbols representing springs, dunes, and ridges, become not only works of art but tangible expressions of place-based identity. Researchers photograph and record the weavers' narratives, embedding them in a digital ethnographic archive that links geological features with living cultural heritage. In the afternoon heat, a coordinated flight of quadcopters conducts synchronized photogrammetry above the inner basin, generating a mosaic of overlapping high-resolution images. These images feed into machine learning algorithms trained to classify surface materials distinguishing gypsum crusts, quartz sands, and lithified siltstones. The output produces thematic maps of surface lithology at centimeter resolution, aiding geologists and ecologists alike in targeting sampling sites and monitoring habitat distributions. As the sun begins its descent, all participants gather at the highest vantage point on the outer ring. Planetary scientists compare their Mars analog findings with the on-site lithology. Paleontologists showcase ammonite impressions alongside modern analogs of fish fossils. Anthropologists display the weavers' textiles against the ridges they commemorate. Remote sensing experts illustrate machine learning maps on portable screens. The confluence of disciplines under a sinking sun highlights the eye's role as a bridge between worlds Earth's concentric chronicle and interplanetary contexts, revealing that the lessons gleaned here extend far beyond the Sahara's sands. Dawn breaks golden over the basin, and our final field day focuses on synthesis and legacy. Under a vast canvas of sky, multidisciplinary teams establish a round table of sample cores, data printouts, artifact displays, and cultural artifacts on a low stone platform within the inner ring. Here, each discipline presents its most compelling insights. Seismic profiles revealing subsurface complexity, isotope maps tracing groundwater provenance, fossil assemblages charting hydrological oscillations, ecological transects detailing biogeographic zones, ethnographic recordings preserving oral histories and artisanal crafts. As the morning sun warms the gathering, a moderated forum unfolds. Young Mauritanian scholars, having trained alongside international researchers, lead discussions on sustainable park governance, education programs, and community-driven tourism. They propose a multi-tiered approach, a core research zone with restricted access, a public interpretive trail with interactive signage, and augmented reality waypoints narrated by Fatimata's descendants, and a digital portal offering global access to 3D models, audio archives, and GIS datasets. The plan integrates scientific stewardship with cultural empowerment, ensuring that the eye's concentric narratives remain accessible to both local communities and curious minds worldwide. At midday, a time capsule ceremony occurs at the geometric center of the eye. Participants deposit into a sealed, corrosion-resistant container, a micro SD card holding digital copies of all datasets, VR reconstructions, and oral history recordings. A printed atlas of high-resolution orthophotos, a woven textile bearing the concentric motif, and a small vial of basin sediment. The capsule is interred beneath a commemorative cairn of local stone, its placement documented by GPS for future generations to unearth and reflect upon the cumulative knowledge of this expedition. In the afternoon's gentle heat, a closing symposium convenes beneath shadecloth. Presenters revisit key themes: the eye as an eroded uplift sculpted by tectonics and erosion, its sedimentary record as a chronicle of African humid periods, its living ecosystems as models of adaptation, its cultural narratives as expressions of human placemaking, and its planetary analogues as guides for interplanetary exploration. The symposium culminates in a shared affirmation that while no Atlantean ruins lie beneath the sands, the true wonder of the eye resides in its concentric dialogue between Earth's deep processes and human curiosity. As dusk descends, casting long shadows across the ridges, participants disperse one final time. Geophysicists collect their seismic arrays, ecologists retrieve their last transect markers, artists fold their canvases, anthologists pack their recordings. In that quiet moment, the basin returns to its silent vigil, the concentric rings awaiting the next generation of explorers. And as the night sky blooms overhead, we depart with the knowledge that the eye of the Sahara, in its endless circles of stone, sand, life, and story, will endure as a testament not to a lost civilization, but to the ongoing epic of planet and people, written in eons and narrated in concentric wonder. And now, as dawn's pale glow creeps across the rim of the eye, our voyage through stone, sand, and story draws to a close. We have listened to the desert's silent testimony, the rise and fall of great lakes, the resilience of life against scorching winds, and the ever-turning wheel of deep time. In seeking Atlantis, we found something more profound and epic, written in concentric circles, reminding us that true wonder lies not in lost empires, but in the planet's enduring rhythms and the dreams they inspire. Carry this vision with you into your waking world. The hush of the desert night, the soft curve of each ridge, the gentle roar of ancient processes that sculpt our home. May the echoes of the eye of the Sahara linger in your heart, a soothing lullaby of Earth's grandeur. And as you drift into sleep, know that this place endures waiting patiently, ring by ring, to share its story with all who listen.